All right, you guys ready? Sorry about that. Now we're good. Finally made it happen. So let's get the party started here. All right, quiet down over there, Priscilla, or you're busted. Ron, you too. All right, here we go. We're into Unit 6. This will be part 1. It's focused mostly on the fuel supply system. So like I was explaining earlier, the fuel system's kind of a big subject. Starting with the supply system, not that complicated. The tank, the lines, the filter, the pump, how we control the pump, and then even a little bit into injectors, the different type of fuel injectors and fuel systems. But where it's going to get a lot more complicated is when we start to talk about the air fuel ratio and all the sensors that the computer is looking at to determine the correct amount of injector spray to make the perfect air fuel ratio, and all the things that affect it, and the fuel trim, and how the fuel trim can make up for like a pump that's starting to make lower volume, or a little cut in your air intake that's sucking in a little bit too much air, right? So there's the base part of the fuel system, that's today. And then there's the electronic input, process, output, computerized part of the system, which will be next time. But that one gets pretty intense. Okay, so this one should be mostly fun. All right, so we'll jump right into it now. Let's just start with this. If we start to get our minds straight, we've talked a lot about the piston and the cylinder and how it needs to make good compression, right? So if the cylinder is going to make a fire, it's going to make a combustion stroke, a power stroke. It needs to have good compression, we agree, which means it needs to have the intake valve open at the right time and close at the right time. It needs to have the piston come down and build compression pretty sealed with the piston rings. It needs to have the exhaust valve sealed, but then after the combustion stroke, we need to have it opened and closed at the right time. Like we talked a lot about that in the first few lessons. And then we talked about the spark plug. So now you guys know the spark plug needs to have that secondary voltage to create the spark to jump the gap on the spark plug. And of course, the spark plug gap has to be approximately correct, and it can't have too big of a gap or too small of a gap, and it has to be fairly clean so it doesn't have like a carbon path to ground. Everything has to be in operation to get the spark. But there's one more thing we haven't discussed as to what's going to make that engine run or that cylinder fire, and that's the fuel. So in this example, this is a port fuel injector, which is probably one of the most easy to understand, I think. But you can see this fuel injector is going to spray gasoline fuel, like in a vapor. You know what I mean by a vapor? Like it's going to be very atomized. It's not going to be like a little dump a cup in the cylinder and have that fuel be really liquid. We want it mixing a lot with air. You want it to be essentially a mist. And so these injectors are pretty good at that. The question is, how much fuel, right? How much fuel? And that's where the part 2 gets a little complicated. That injector can spray a little bit of fuel, a little bit more, a lot more, right? If you look at it on a scale of 0 to 100, typically it can spray as little as 1%. It can spray as much as 99 or 100%. So it's a big range of how much it can deliver. But we got to get the fuel to that injector appropriately for it to spray the correct amount, the correct quantity, right? So let's say that if we were to get started, we talk about the fuel pump. If your fuel pump is not working at all, how much fuel is going to spray out of that injector? Nothing. So that's going to be like a no start, because your fuel pump supplies fuel to all the cylinders. Make sense? So if you go to start a car and it's just a click and there's no crank, we're more concerned about the battery, right? The starter maybe. But if you go to start the car and it goes, no, 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 you're like, wonder what's going on here. Maybe it's got no spark, maybe it's got no fuel, maybe it's got no compression, right? So we're now to like, if you're looking at those three, we're now on the third subject. So once you get this one, you should be able to diagnose all those crank no starts, like no problem. If the fuel pump's no good, you got no fuel to any cylinder, you're gonna have a no start. But what if it's a little more complicated? What if your fuel pump, you're expecting to make 55 psi, but it's only delivering like 30? What do you think might happen? It's going to spray fuel, right? But you think it's going to spray like enough fuel? So probably not. And that's where it may start, but like you may try to accelerate. When you accelerate, you need a bigger volume of fuel. And if your fuel pump can't keep up, you're going to be starving for fuel. It's going to have fuel starvation, loss of power under wide open throttle. But like at idle, everything's fine. And then you go to punch it and it's like, ooh, and you're like, let's go here, right? So it can go from a crank no start to like a loss of power to, on the more modern system, we can detect that it doesn't have the correct air fuel ratio and it's having to spray the injectors a lot more to get it closer. And that could be because of a worn pump, a clogged fuel filter, maybe even an issue where, you know, there's air being sucked up into the fuel system. There's a number of issues, right? So this is kind of where we're at. But to really understand it right, I think you need to know a little bit about gas. All right. So when we talk about gasoline, that you think gasoline means gasoline, right? But it kind of doesn't. So back in the day, gasoline was just gasoline. And then, you know, we're kind of like, well, we got all these farmers and the farmers are growing corn and we got nobody who wants to buy the corn. So like, I know, we'll start like refining that corn and mixing it in and we'll make it like maybe 10% corn alcohol, which would be ethanol, right? And so gas could mean a number of different things, but we'll kind of go through that. When we want gasoline, the go-go juice, if you will, we need oil. We need old dinosaurs and stuff or whatever. So we're going to pull that crude oil out of the ground and we're going to really need to refine it, right? So this is just a picture of the refinery. The refinery is going to take that crude oil and we're going to separate it into different things. Like if you want Vaseline, that's the brand name, petroleum jelly. We're going to get your petroleum jelly from this refinery as well. But what if you want propane and propane accessories? We're also going to get propane, but probably not the accessories, also from the crude oil at the refinery, right? So the refinery is separating the crude oil into all these different products, some of which may include some lipsticks are you know, in a way from the refinery because they're petroleum based. And then something even like jet fuel or diesel. It's all coming from this, but we got to refine it to a specific specification, okay? And then a lot of times we'll mix it with some things too. So this is where we make the gas. Cool. And then from there, here's something. Who's ever thought about octane? 91 is better, right? Well, I mean, is it though? It kind of depends. So there's octane and there's cetane. So octane is slower burning, more resistant to burning. So if you look at it, if you want fuel to burn really easy, you actually want a lower octane, like a 70, but you can't really buy that here. You can buy 87. Our cars are really made for like a range. Like 87 would be your standard, you know, cheap gas. Well, we use that term loosely. Cheap gas is kind of a bad term. 87 octane is fine. It can be very high quality 87 octane, and that could be exactly what your car calls for. And most typical average, like economy cars, do call for 87. There's a reason they call for 87. If you think you're helping it out by running 91 octane, I'm not really sure about that. It kind of depends on the application. Now, if you've got a car that's supercharged, turbocharged, really high performance, and it calls for 91 octane, yeah, you really need to run the 91 octane. But if it calls for 87, you're running 91, I'm not sure that you're getting your bang for your buck. In fact, I bet you're not. So let's just focus on octane for one moment. Go ahead.
What about your motorcycle?
I actually don't recall what my motorcycle calls for, but it absolutely gets 87 every day. But a couple of my dirt bikes definitely call for 91. So if it's like a commuter motorcycle, probably 87. But if it's like a high performance, 91. I'll explain exactly why. Look down here, slow burning. If we look at our octane, I'm gonna kind of walk away from the slow to the fast, and I want to talk more about how resistive it is to combustion. That's the way I visualize it. I think it makes a little bit more sense. If I have, let's just say, I'll kind of keep my motorcycle, but I'll kind of make it a little more generic. We have a daily driver Honda 4-cylinder. That's an economy vehicle. Mine happens to have 2 wheels. That's all it is to me. Don't even be, that bike is a good bike, but like that bike's essentially a Honda Civic to me. It gets me all over the place, and I'm pumping 87 every day. That's more of like a commuter typical, not super high compression, not super high performance. It's just made to drive. If it doesn't make a lot of compression, this 87 is going to hold up just fine. Now, the problem would be if I were to take that daily commuter Honda and throw a turbocharger on there, the turbocharger is going to pressurize the air more. Isn't that going to be putting the cylinder under more pressure? So like if you have maybe typically you're expecting to have a cylinder pressure of like 190 PSI and you turbocharge it or supercharge it, now you're getting 210 PSI in the cylinder. That fuel's under more pressure. The reason that's critical to know is, remember how when we heat something up or when we compress something, it heats it up? It's going to tend to get that fuel ready to combust. If you pressurize it too much, you heat it up too much, you know what'll happen? It'll combust right then and there. But wait a minute, we didn't spark the spark plug yet. Doesn't matter, right? So if you take that daily commuter that's running 87 and you bump up the compression by increasing your piston deck height, like if you put a high compression piston or you supercharge, you turbocharge or whatever, on compression stroke, it'll get to the point where it makes so much pressure, the fuel will start to combust. You no longer have control of that combustion. That'd be like pre-ignition specifically. So if you get pre-ignition, now all of a sudden you're like, we got this flame front starting because the fuel ignited itself on compression, kind of like a diesel. Then you got the spark plug, and the spark plug's like, all right, I've waited for this moment. Spark it. And it's like, dude, we're already burning. Like, this is out of control. You're losing control of that engine. And you're also going to probably have those flame fronts colliding, and that gives us some of our sounds of like spark knock or detonation, these types of things, right? So that's a big problem. So if we supercharged, turbocharged, or increased our compression on our daily driver, what do we need to do to make sure that we don't lose control of that combustion? The higher the octane, the harder it is to start the ignition process. So if you put 91 in it, now the piston's coming up and it's like, you know what? We can handle 210 PSI of pressure in this cylinder running. The fuel won't pre-ignite. Make sense? And then when the spark plug sparks, it's like, yeah, now is the time. This is what I've been waiting for. And it actually is a controlled burn and it's precise. And we're going to actually have, a better power stroke because we have control of it. And so 87 is really more for like your lower compression engine. 91 is for your higher compression engine. Which one do you have? That's the fuel that you need. It's that simple. If you have a compression that's a daily driver, 9-to-1 compression, you put 91 in there, you're not helping anybody. You're not helping anything. However, if you have an engine that's fairly high compression, it's let's say, I'm looking in the parking lot. I'm going to imagine something different in the parking lot. It's a Corvette Z06 supercharged, or if it's a newer one, turbocharged, twin turbocharged, right? That's going to be under a lot more pressure. That car calls for 91. It demands 91. If you put 87 in there, the opposite will happen, right? You've got the high compression, the super turbocharger, super boost, and that 87 starts to let go early. It starts to pre-ignite. Your ECM is going to get a signal from your knock sensor and be like, whoa, I'm pretty sure that we got pre-ignition here. I heard it with my microphone knock sensor. What it's going to do as a result, it's going to take your ignition timing, it's going to retard it. It's going to start making it much, much later to try to get it under control, try to cool the cylinder, try to calm it down, and you're going to lose a massive amount of power just because the computer is going to pick up and retard the timing. So this is where some of these, rumors, you might say, or false information, you might say, come from, so trust the science. Here it is. If you have a high compression vehicle and you put 87 in, it's going to catch that and it's going to retard your timing. You're going to lose power. So like, oh, my car doesn't run good on cheap gas. That's true. It's true. It doesn't run good on cheap gas. Then you put 91 in it. It's like, it might take a while for the computer to continue to slowly advance the timing. But then once the timing is back up to advanced, you get all your power back. And like, see, it runs way better on 91. So 91 is better. Well, like that's only because that's an engine that really called for 91. See, if you take your regular daily driver and you throw 91 in there, I'd be very curious to hear your scientific results. I don't think you're going to gain anything at all, except you paid 20, 30 cents more per gallon, and that's it. And maybe you feel it like the placebo effect. You could be like, oh, it just feels better, and be like, if I were to switch the stickers, it'd feel better with 87. You'd just feel better about it because the stickers were switched, you know? So there's some little bit more research we could do to make it more scientific, but trust me, there's a reason if the manufacturer calls for 87, you run 87. That's what it's made for. There'd be a negative actually of running 91. If your car doesn't make that much cylinder pressure and you run 91, it can be a little bit hard to get that cylinder hot enough, and they can tend to actually leave some carbon behind because you're running the really high octane. That fuel is a little bit more resistive. It's slower burning, right? It's a little more resistive to full combustion. You might be leaving little bits of fuel behind. That's actually going to lower your fuel economy, but those bits of fuel are going to cool onto your piston and things and become hardened carbon deposits. So if you got an engine that's kind of running too cool and leaving fuel behind, it'll be carboned up. You're not helping at all. Okay. Kind of good on octane. It's not really super complicated. I like that one. I'm going to answer that, but I'm going to answer it a little bit later when we talk about fuel additives, because that's a relevant point too. All right, so if we're decent on octane, this is true for all types of fuels, right? So when we start to get into that ethanol, right? Like I was saying, we got the farmers, and the farmers are having this corn and we don't know what to do with it. So we start mixing 10% in. If you buy gasoline today, you're getting really 90% gasoline, 10% ethanol. And if you buy full on flex fuel, if it's E85, you're getting 85% ethanol and 15% gasoline. The ethanol has a different octane rating. So it can be somewhat beneficial because we can get our octane level a little bit higher using some ethanol. So ethanol does have a much higher octane rating. That's part of the reason you'll see these crazy race cars running E85 with like huge turbos and tons of ignition timing, very advanced, and making a ton of power because, well, gasoline high octane at 91 is, you know, the best we could do. You can buy race gas at 100 octane or whatever, but that ethanol is high octane right out of the gate and it's cheap. It doesn't have great range though. All right. Now the opposite is true. When we get into cetane, and this will just be something kind of basic, cetane is more of a concern with diesels. So like if, let's say you had a diesel, we don't have spark, right? How's the diesel ignition occurred? Remember? Straight up compression. So it's kind of like pre-ignition, but we don't call it pre-ignition because we want it to happen, right? So that diesel making 20 to 1 or 22 to 1 compression comes up. It's under so much heat and pressure. The diesel's like, all right, let's start burning now. Well, let's start burning now depends on the cetane rating. So if you have like, let's say you took your diesel and you went to Fairbanks, Alaska. It's going to be really cold there. It's going to be kind of hard to start that combustion, right? So you'd actually want something that's faster burning. You'd want something with a higher cetane rating. So they might be selling a different cetane rating in the winter than they are in the summer. They may have a different cetane rating in Alaska than they do in Southern California, right? So cetane is kind of the opposite of octane. We're just not usually super worried about cetane when we're talking gas because we're usually kind of trying to have to make the gas like more resistive to burning, not make it burn easier. It's already burning pretty easy. Diesel will be more down here. Cool, but they apply to both. Now, if we were to look at gas, like this gasoline could be different than this gasoline. All right, so 87 octane is just the measurement of the octane rating, and that's it. It's not a measurement of how many cleaning agents or any sort of these additives to make your vehicle, your combustion chamber stay cleaner, or especially when we get into the other types of fuels like diesel tends to gel up. They can change the amount of additive that they put in the diesel to stop it from gelling, right? The octane and the cetane are just measurements of the resistance to burning or how easy it burns. when we get into additives, there's a lot of other stuff. So if we were to go way back to that refinery, right, we're starting with crude oil, and more than likely, let's make this an Arco versus Shell argument, shall we? What do you want? Shell, Chevron, pick some. Who? Oh, Mobil? Yeah, we could do that. All right, so this is Arco. I don't know. Okay, we'll go with that. Or you want to make anything more interesting? Something abnormal? VP race fuels? I don't think Walmart sells gas. All right, let's go. We could do Costco gas. You know what? Costco makes sense. Let's do Costco because actually I know what Costco says right when you roll in. All right, when you go to Arco, and Arco, I'm not really trying to knock Arco right now. Arco, I don't know how their fuel is, but I heard some stories from back in the day. Arco 87 was like a bad joke. They'd be like, Arco 87 is trash. And from what I heard, it actually used to be. Now it's probably fine now. But Arco 87, it was 87 octane, but they had minimal additives in the fuel, right? So if the crude oil gets pumped from the ground in Saudi Arabia, and then they take that crude oil and we're going to bring it over here in barrels. And I don't remember what the price of oil is, right? But Arco is buying barrels of oil for the same price as Costco is buying barrels of oil. Make sense? So once they get here, then they're going to start doing more of the refining. And so they can refine it down to gas. Now you got gas, right? After that, Arco may decide to put this additive, that additive, that additive, and this quantity. Make sense? And then let's say Costco, of course, it's going to be like Kirkland Select gas. It's going to be like, let's put double the additive, put an extra additive, put a cleaning additive, put this additive, put that additive, put an additive in there to make it last longer, put all, right? So it was crude oil shipped, then it was refined to gasoline, and then we put the additive package in. So you may be getting a different additive package from Arco as you are from Costco. What I remember about Costco specifically is when you roll in, you ever notice it says a thing, top tier fuels? Well, what top tier fuels was, several manufacturers got together and said, you know what, we want this much of this additive, this much of that additive, this much of that additive. That's going to be what's best for our cars. It was a long time ago, but when I went to school, they were first talking about introducing top tier fuels. It wasn't even a thing yet. And GM was saying, yeah, we really want these top tier fuels. And we get customers and they come in and be like, hey, you know what, I have this extended crank, or I have this concern, I have that concern. And, you know, sometimes what the technical assistance center would tell us is be like, yeah, tell them to get a top tier fuel. We tell them like, you got to get a top tier fuel. And they'd be like, what the heck is that? Be like, Google it. Google was kind of new, right? But if they found a place that had a top tier fuel, honestly, it would resolve their issues a lot of the time. It's pretty gnarly. So it was like, whoa, get a top. But wait a minute, this is 86. You telling I need 91? Like, no, not the octane. A top tier fuel is a different additive package, and it would actually resolve some things. Now, I've heard it the other way too, in fairness. So I'm not taking a side. I haven't done any of the actual tests myself, but we got some dealers that are saying the customers have some concerns with Costco gas, and they tell them go to a different gas station. Those customers don't come back either. Now, I kind of suspect that they're just not willing to give up that Costco gas price. So they're like, you know what? If I got to live with this little extended crank or this little whatever, I'm still pumping Costco gas, because they're like, you know, it's like a cult kind of, like it's hard to get out. So I don't really know all the facts. I'm just saying Arco and Costco started off with the same crude, but the additive packages are going to be different. Makes sense. And it's the same for the other ones. I don't know what Walmart has. I don't really exactly know about Mobil or like Chevron or any of these. I'm not totally sure, but just know they can be a little bit different, right? So when we go to do some of our diagnoses, you can consider it. And I got a video I'm going to share with you guys, a customer, and that's kind of relating to this. His gas gauge doesn't work, you know, so that's the first problem. That's kind of related to fuel systems, because the level sensor is built into the pump, the pump assembly sending unit, but his gas gauge didn't work. He was driving, he ran out of gas, he assumes, but how do you know? Because the gas gauge doesn't work. But he was, and is in a Subaru BRZ. Right? That sounds like he ran out of gas. But he could have lost spark, you know, due to a crankshaft position sensor, or he could have lost, maybe the fuel pump went bad, or I don't know. There could be other things, right? So he thinks he's out of gas though, and it was kind of dark. And I'm actually struggling to remember his name right now. I just talked to him. Well, whatever. I'll think of it randomly. And so he calls his buddy and he's like, "Hey, I ran out of gas. Can you bring me some?" And the homie had a gas jug that had been sitting around for a little while. That's a bad sign. Okay. Been sitting around for a little while. I was like, "Yeah, I'll help you." And it was dark outside. So when they put the gas in the car, they couldn't really see it. But he was saying as he was filling it, it smelled kind of weird. Right. So there's some signs. And then sure enough, it kind of started up and it kind of stumbled and it ran a little bit and then it died. So by the time I get there to his house, the back bumper's broken. Why do you think? He's like, "Just get behind me and push me." So he pushed one car right up to the back bumper, this BRZ, and just shoved them all the way home. But it wouldn't even run at that point. And so it was kind of like, it was nice because he at least told me the truth. It was like, all right, when I roll up to a crank no start, because that's what it would do. You'd go to crank it and be like, "Shana no 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 no." Once in a while, I'd go like, "Boop boop 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 no 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 boop boop no 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 no." It's like, okay, we got to do some diagnosis. Does it have spark? Does it have fuel? Does it have compression? But he told me like it was running good. I think I ran out of gas. I put in gas. It smelled weird. It started up for a second, then it died, and now it won't restart. And I was like, yeah, you know what that sounds like? Kind of sounds like you might have put in bad gas, you know. So not even testing a whole lot, I already had in my mind. So Diego, that's his name. So I was like, "Diego, good job telling me the truth." Customers, though, they don't lie to your face. They'll be like, "Oh no, I didn't know what happened." You know, and next thing you know, the car comes in, it won't run, and you're doing all these tests, and you come to find out that they filled it with diesel. And it'd be like, "Hey, why didn't you just tell me that at the beginning?" Like it's not that easy to tell when a car's had diesel pumped into it. You know, like I mean, you can go and start sniffing the gas tank. That'd probably actually not be such a bad idea. But normally we're checking codes and we may be checking spark and we might be looking at compression and like you're like, did you really why didn't you check to see if they had diesel in it first? It's like that's not really normal. Like cars come in with bad crankshaft position sensors all the time. They don't come in that often that have been filled with diesel. You know, so it's nice when the customer tells you the truth, right? So this guy cut it straight with me. I'm like, you know what? I know what tools I'm going to bring. A 5-gallon bucket that's empty, a couple tools to undo a fuel line, and my scan tool. So sure enough, I go to crank it, go to start it, won't start. I pop a fuel line off. I take a water bottle. I go in my scan tool. I command the fuel pump on, and the fuel pump runs. And I drain a bunch of fuel into like, to be honest, it was just a water bottle. I drank the water first, and then I tried to shake most of the water out, and then I filled it with fuel and I swished it around, and then I dumped that out into the 5-gallon pail, of course, and then I pumped more, and so I hold it up. That tells me just about everything I need to know. So when we look at this, when we're testing fuel, this is a lot of times how we test it. This can happen in the shop too, right? So is the fuel good or bad? Sometimes a little hard to tell. If you guys have ever smelled bad fuel, it smells like kind of like paint thinner or something. It's just nasty. Your fuel, if you pump it today, it's probably good. A lot of fuel companies will say like 90 days. So you got 3 months. If you pump gas today, 3 months from now, you better have burned it up and done something with it. I've seen it go for 6 months. I've even seen it approach a year. Anything after a year, that thing's gonna be messed up. So if you put fuel in something, a dirt bike, I've had this too many times. You don't use it for a year, and then you're like, "Oh, I finally got a day off. Let me go start my bike." I got to clean the carburetor again. Like it just doesn't last that long. Fuel does not last that long. It's perishable. It expires. Okay, so everybody knows. If you go to try to test it, a lot of times what'll happen, you'll take a sample like this, and you see a separation here. We got kind of like a gray, and then we got kind of like an amber. I can't totally tell what we got right there. It looks to me like the gray is water, but we shouldn't have that type of separation, right? There's some contamination in that fuel. So that's what I did when I swished this water bottle around. Honestly, literally the bottom half of it was water and the top half of it was gas. He had 50% water and 50% gas. How'd the water get in there? It's like, how? I don't know. Okay, ethanol is an interesting thing, and we cover that in just a second, but ethanol is alcohol. I wouldn't drink it though. I mean, I guess you could. I think it's kind of like in a way similar to moonshine. The thing is though, that alcohol, it tends to attract the water, right? So if there's any moisture in fuel, it tends to be like a little molecule here and a molecule here. But when it's got the ethanol alcohol in there, the ethanol just grabs the water, right? So now you have ethanol that's got a bunch of water, and water and oil, they separate, right? So if you remember, gas was petroleum based. So this is kind of like oil based. This is kind of like alcohol that grabbed a bunch of water. Now you got the water really separated from the gas. And so when I did that sample, I was like, dude, you got so much water in here. How long was this sitting around? Because if you have ethanol in there and it collects water, if that fuel is not sealed, it will continue to pull moisture into it right from the air and just collect and collect and collect. I don't think that someone put water in it. I think that the ethanol collected the water just from not being perfectly sealed, right? So, of course, the fix was get that 5-gallon bucket over here, command the fuel pump on, and I just let the pump the tank empty as I could, and then filled it with some fresh fuel, and boom, fired it up. And it didn't run perfect, but it ran pretty good. And I said, like, burn this whole tank of gas through here, and then the very next tank will be like any signs of this watery old ethanol bad gas will be gone, So it wasn't really rocket science, but if you don't know about it, it's kind of hard to figure out. So he kind of knew, but he didn't really know what to do about it. There's no drain plug on the gas tank. If there was, people would be stealing your gas tonight. And sometimes they make a drain with a drill. All right. So when we get kind of into this a little bit later, what you got to understand is that for gasoline, the correct air fuel ratio is 14.7 parts of air to 1 part gas. Now we're assuming it's good quality gas now, right? So now we're good on now we're good on like what gas is, and it shouldn't have water, and it should be like 90% gasoline and 10% ethanol, and the gasoline should have the additives. Well, if all that's true, to make good clean combustion, we need a 14.7 parts of air to 1 part of fuel. But understand this, it's not by volume though, it's by weight. So like if you looked at this room and this room was 14.7, and then you had gas was just going to be like this corner over here, that's not really how it is. It's not by volume, it's by weight. You would need 14.7 pounds of air. That's a lot of air. To 1 pound of fuel. That's just a little bit of gas, right? That's the ideal ratio. But as we get in a little bit further, we're always chasing this, right? So this is why I put it closer to the beginning, is like we're always chasing this exact ratio. Stoichiometric or stoichiometric, you can pronounce it several different ways. Okay, so that's our ideal, and it's a little different, by the way, for ethanol, and it's different for if we have different variations. It's the same for 91 and 87, but if you have like E85 or E10 or E50-50, it changes if it's a different ratio of gasoline to ethanol. But if it's gasoline, it's 14.7 to 1. Okay, so we're going to be chasing that one. Then as we go to do that fuel sample, like this is what I did. I collected the sample, and you can see that looks kind of amber. I mean, that could be normal, but sometimes when gas gets older, it gets oxidized, and it does tend to change a little more yellowy. That one to me is a little sketchy. That one's like a little like, I don't know. If I were to smell that and it were to smell like kind of like, I don't know, old gas has a certain specific acquired taste of a nice, tap it on for the evening, make it look good. I don't know who you're going to attract, but it could attract someone. It smells bad when it's bad. That's the number one first test for me. I'll smell it and be like, does that smell like gas? No, it smells like paint thinner. That's bad. But you could do it like this, collect the sample, and then believe it or not, what you're actually going to do is you're going to put water in the test tube on purpose. You're like, what? Why? That's crazy. Remember how the water and the alcohol are attracted? This is going to pull the alcohol out. So we need the water in there to do a proper test, right? And then we're going to do 90 milliliters of gas. Okay, so 10 water, 90 gas. and that'll bring us up to our 100 number. Cool. And then a lot of times what we'll do is like cap it and then agitate it. You know what that means? Like shake it up, let it do its thing. And then you're going to let it sit there for a while. And when you're shaking it, any alcohol is going to be absorbed by the water, right? So it's going to separate it. Then you're going to let it settle for a while, and then you can actually see the separation. So we had how much water before? We had 10, right? Why does it now look like it's way up near close? Let's call it at 30, right? It's more like, I don't know, 28, but let's call it 30. Why do we now have 30 though? All right, so if we had 10 and we had alcohol dispersed throughout the gasoline, and now we have 30, that would tell me that there was about 20% alcohol in there because we added 10 water and now the 10 has become 30. That's a way to determine the percentage of ethanol in the gas. Yeah, exactly. Now the water grabs the ethanol and now it's an ethanol water mix. They just go together. It's hygroscopic. It's going to mix up and you'll be like, oh, wow, there's actually 30. But remember, we added 10. So it was really only from 10 to 30. It was about 20. And this one, in this case, a little bit less. So this may be like E18 fuel or something. And E10 is, if you roll up to the pump right now, you're pumping E10. It's 10% ethanol, 90% gas. This one was not 10%. This one was a little bit more. Now the problem is your vehicle's expecting E10. That's how they're manufactured. Now, it's been a long time since we put ethanol in there. It's not expecting E18. So this one's going to run a little funky. It's going to have fuel trim. That's next lesson. The fuel trim is going to be off, and you can check all the sensors in the world, and you're not going to find a problem because the sensors are not the issue. The quantity of ethanol in the fuel is the issue. And so this test would have revealed that and be like, hey, this has got like 18% ethanol rather than 10. That's going to have my numbers off. Okay, makes sense. So that's a good experiment, right? And then, of course, you got to dispose of it properly. Cool. And then just going over ethanol a little bit, it's a plant-based material. So like what I was saying, it's generally going to be corn. We're going to harvest this field, and then we're going to distill it and get ethanol out of it. Which is the alcohol. And so here's some fun numbers. Like if you look at octane, let's just discuss octane. Gasoline could be 80 to 90 normally, and then we're going to add a little bit of a octane increaser, octane booster if we want that 91 and stuff, right? Look at, oh, that's the motor octane, research octane. Sorry, I should be looking at that one. Octane 92 to 98 for gas. Ethanol 107. So you're like, whoa, ethanol is really good. Well, like good as long if we're talking about octane, yes. Octane is the resistance to the burning, right? So if you want to do supercharger, turbocharger, big old, high compression race car stuff, and you need the high octane, it's pretty hard to get 107 out of gasoline, but ethanol comes with 107 right out of the gate, how they research it. So it's like, hey, ethanol is pretty cool. Here's the negative, though. There's actually less energy. There's less BTUs, British thermal units of energy within the ethanol. So you're going to actually have to increase. You're going to have to burn a lot more ethanol than you would gas to hit the right numbers, to have your emissions levels correct, and control your combustion temperatures. So it's better fuel when it comes to high performance and being able to advance the timing and having the fuel not pre-ignite. But as far as like, if you had a car that would go 300 miles on gas, it's probably only going to go 200 miles on ethanol. So is it better in that way? Kind of. It's like on one end of the spectrum, you got 100% gas. Not real high octane, but it's got a good fuel range, got a lot of energy per unit, right? Per gallon. But then you got ethanol, and ethanol's like, whoa, we can throw a lot of supercharger, turbocharger timing and get a lot of power, but it doesn't have as much energy in it, so you're going to burn more of it, right? So if you run 100% gas, if you run 100% ethanol, flex fuel is anywhere in between. So a true flex fuel vehicle will allow you to run either gas or ethanol or E85, right? Or any mix. So if you go to Costco and you pump up top tier fuel 87, you just fill it to halfway. Then you go down the road and you go to Shell and they have ethanol, you can put E85 in there. Now you have a mix. It's not quite 50-50, but it's like, I don't know, let's say it's like 47% gas and 53% ethanol. The flex fuel sensor will pick that up. The computer will adjust. It'll adjust all the timing, the fuel trim. It'll adjust everything, knowing you have a mix. So when it says flex fuel, it means it's flexible. This one or that one. A little bit of this, a little bit of that. You could do anywhere between E10 all the way to E85. Above E85, more ethanol than 85% is out of the range of what it's going to be designed for, though. So, yeah, I mean, to dumb it down, E85 is cheaper, but you need to pump more of it. So I'm not sure there's any savings at all. In a way, it's more inconvenient because now you got to fill up at 200 miles rather than 3. So I don't know. Depends. You could do the math. I think it depends on the exact details, but it's not miraculous. You know, it's not amazing. I'd say the main, if you look at who's really big on flex fuel, it's a lot of the domestics. And the reason why is the government was very pro E85. And so when the government fleet vehicles, like let's say the county or the state is like, hey, we're going to buy vehicles, they should be green. And they're like, yeah, buy flex fuel. It's better. It's better. It's better for the environment. It's better. They'd be like, yeah, we're going to buy flex fuel vehicles. So Ford and GM and somewhat Chrysler were like really big on flex fuels, mainly to sell to government fleets. I don't think it's saving the average consumer any money at all. I don't think so. Yeah, but maybe it feels a little bit better because you only pay $50 for the ethanol, but you're going to pay $50 and go 200 miles rather than 75 and 300 miles. I don't know, same, but different. Cool. And then of course we could throw some other things. You could look at like methanol, and sometimes we'll do like a methanol injection and make it so that methanol will help to increase your octane if you have a race car and you don't want to do 85, right? So there's all sorts of stuff that we could do, and it's all just because of the octane numbers. All right, so that's essentially all I've got about fuel itself, which I think you need to know a little bit about. Now let's get into the components. So going right from top to bottom here, we're going to cover each of these. The fuel pump, that's important. The fuel pump pumps the fuel. It moves it. The fuel sending unit is kind of like a housing that carries the fuel pump, but it's also going to have, you know, some things bolted to it, mounted to it, right? So the fuel pump is small. It's like, you know, it's like 2 inches long, round, but it's installed in a much larger housing. That would more be the sending unit. Okay, and a lot of times we'll lump that in with the fuel level sensor too, because the level sensor's got an arm and it's attached to the fuel sending unit. So that's going to go up and down and tell you how much gas is in there. Then of course the fuel tank, you know what that is. The fuel filter, and I would say if it has one, but they all have one, it's just not what it used to be. The fuel pump control module is kind of unique. Old cars didn't have a fuel pump control module. They didn't need a fuel pump control module. The fuel pump was turned on or off. The only reason we'd need a fuel pump control module is if we're going to try to vary that output of the pump, right? So back in the day, we just send the pump full, pump everything you got all the time. And that was, it's one way to do it. It was kind of hard on the pump though. Now, if it's at idle, we can have a fuel pump control module, slow the pump down and be like, hey, you don't need to like pump all crazy. Like it's just at idle, chill. But we need a computer to control that. That's what the fuel pump control module is. And then the fuel pressure regulator. And this one can get a little tricky. This one's changed. It's moved. It does the same job, but it looks different on new stuff. So it regulates the pressure. If we want 55 PSI of fuel pressure, we need the regulator to give us 55, not 48 at this point and 57 at the other point. You want it consistent so that the computer can have a consistent reading, so it can try to hit that 14.7 number. Remember that number? 14.7 is the correct ratio. If your fuel pressure is all over the place, the computer's gonna be like, whoa, more, less, more. It's right. It's to stabilize that pressure. Cool. Start with the fuel tank. Here's a couple options for you. We've got a nice, big, long, what appears to be mostly a metal fuel tank. Sometimes they're all metal, but in this case, I think this is a plastic tank, which we'll cover. HDPE, high density polyethylene, I believe, but let's call them mostly plastic, but it'll probably have like a, why do you think they'll put the metal on the bottom of the tank? Does that look like a truck? It looks like a truck to me. Why do you think they got a metal plate on the bottom of the gas tank? Yeah, you think that you want to do like, hey, I got an off-road TRD Tacoma. I took it over one rock and the rock punctured my fuel tank, spilled fuel all over, caught on fire, and burned down the national forest. Like, it'd be a good idea to put a little metal plate on there. Let's put a metal plate on the bottom of that truck. Makes sense. Yep. Right. And so what if and now metal's still out there. Metal, a lot of people would say metal's better because you're less likely to puncture this, but there's a couple issues. One, metal conducts electricity, so it's more likely to potentially have a spark. And I don't know how common that really was, but this is good while it's new. What do you think about when it's been sitting out in the weather a while? Rust. And if you get rust on the outside, there's going to probably be rust on the inside. And if we get rust on the inside, where do you think that rust is going to end up? All up in the whole system, right? So we got a filter, hopefully that's going to catch some of that, but like your filter can only catch so much rust. If the whole thing is rusting, that's not good. And yeah, they're going to get in our injectors and clog our injectors. So metal fuel tanks is going to be probably mostly like going away. I don't really see those anymore. The plastic, loosely, HDPE is going to be more, it's the standard. And if we're worried about it getting punctured, we're probably going to put a skid plate on there. Makes a lot of sense. Cool. And then additionally, a lot of times we're going to put like all the time here, we're going to have like a whole vapor collection system called the evaporative emission system. And I do intend to at least get loosely introduced to that before the end of class. Cool. So blow molded is just the way that they're manufactured. This one, for example, doesn't have a skid plate. This would be like a non-off-road package. So maybe it's a two-wheel drive truck. They'll be like, nah, you better not be off-roading with this. We're not going to put a skid plate on there. Save the money. And then additionally, when we're talking about hydrocarbon, so the fuel is a hydrocarbon. Gasoline's a hydrocarbon. If you vent it to atmosphere, it's damaging the atmosphere. Global warming, climate change, it's greenhouse gases, it's that type of stuff. So the fuel tank's job is to not only hold the liquid fuel, the go-go juice, but it's also to store the vapor and be sealed. However, we need a way to vent new air in as the fuel level goes down. So we're going to have this whole evaporative emission system, but these tanks are actually really good at containing those hydrocarbons. That's why you need to have the gas cap on. If you leave your gas cap off, what happens? Yeah, you're going to get a check engine light for an evaporative emissions leak, and they'll be like, you are allowing hydrocarbons to enter the environment. Your check engine light is on, you fail smog. Makes sense? So that's really the whole reason right there. Makes sense? Did you know if you had a hole in that fuel tank, you'd get the same check engine light? If it's all the way at the top of the tank, you might not see any fuel leaks, but that system will sense that that tank is not holding pressure and containing hydrocarbons. Check engine lights on. If it's a small one, it may be like a very small evaporative emissions leak. If it's a big one, it may be like a gross evaporative emissions leak, which isn't because it's nasty. It means like it's totally not holding. It's grossly failed. It's complete.
You don't have the sensor going off at all.
No mill? I am not sure how it could be a leak and have the system not catch it. I'd be very surprised at that. System would be paying some attention. If you got something specific, maybe we talk about it while the government's not listening. Now I'll check it out. But like if you have a liquid fuel leak, it may not catch it. It doesn't really monitor the liquid fuel. It monitors the vapor pressure on top of the fuel in the top side of the tank. So if you've got a drip right here, you probably won't have a check engine light. That's true. But if you do have a vapor fuel hydrocarbon leak, that system, I'm going to bet you, is going to catch it. unless there's some weird malfunction, which would be a little strange. All right, so if you look at how the system flows, fuel tank holds the gas, right? The fuel pump, anything that's like not carbureted, so like anything in the late 80s to early 90s and newer, so for a long time, 30 plus years, the fuel pump is going to be inside the gas tank, submerged. And actually, that makes a lot of sense to me. At first, it was like, these engineers, they could put the fuel pump somewhere where it was easy to get to, but instead they put in the gas tank because they hate me. And like, you could think that way, but the truth will set you free. And so the reason it's submerged in the tank is pumps don't like to have to suck really hard to pull fuel up. They do best when they push. So if we set the pump in the fuel, it's just getting fed with as much fuel as it possibly needs, and it can push it all rather than try to draw it all out. Pump's going to last longer. This is a much better design, much longer lasting for the fuel pump. Makes sense? And back in the day, if it was carbureted, our fuel pumps only needed to make 6 PSI. But on a new car, this may be as low as 50, and maybe as high as 80 PSI, 90 PSI fuel pressure demand. That little fuel pump, like up on the engine block, like a carbureted, that fuel pump is not going to last long if you're trying to have that thing draw all that fuel all the way from the tank and produce 80 PSI. That fuel pump's going to be hammered. And in fact, those mechanical pumps weren't that good anyway. Right? So there is a good reason why it's in the fuel pump and the fuel tank. The negative for you, it's in the fuel tank. So you're like, oh, it needs a new fuel pump. And you're like, oh, what do I need to do? You may have to drain the fuel tank. You may have to take the fuel tank down. On some cars, especially like a small performance rear wheel drive, because they needed a larger fuel tank, but it's a small body. Sometimes the fuel tank goes over top of the drive shaft. Other times the fuel tank is, really long, like on a big truck. They're kind of hard to handle. The fuel tanks come in all shapes and sizes. If you got to drop the tank to do the pump, it's going to be a job, right? It is what it is. We're going to charge the customer appropriately for the job. If it was an easy job, we'll charge them less. You got to get paid for your time. So if you've got to drain the fuel and remove the drive shaft and remove the exhaust and remove some other stuff and then remove the tank and then you do the pump, it's going to be an expensive repair. It just is what it is, so maybe in a way the customer kind of loses out. But the good news is, partially because of the high quality parts, but also because of the design, this fuel pump should last quite a while. So if this fuel pump lasts 200,000 miles and then it fails, it's sort of like, well, who cares that it's in the pump? Like, it already lasts the life of the vehicle. The vehicle, it's got 200,000 miles on it. Whoever bought that car new is thrilled with that 200,000 miles. They're like, I bought a brand new car and it went 200,000 miles and I didn't even have to do the fuel pump. That's great. Now, when you're buying a 25-year-old hoopty, my bike's a 2002. I can speak to this. Okay. So it's maybe not quite that old, but close to, ish, like 23, 24 years old. And the fuel pump goes bad. You could be like, oh, they made it so hard to get to. And this fuel pump's junk. Like, that fuel pump's been working for like 24 years. Like, give it a break. And 200,000 miles, which I don't have quite yet. So, but that's kind of the outlook on it. It could be a big job or a small job, but from there, it's going to go into the line, right? This is a return style fuel system. Okay. So one of the things I want to show you, it's going to pump it up in the line. It's going to go through the fuel filter. What do you think the fuel filter does? Yeah, it's gonna clean it up. It's gonna filter it. It's gonna catch that rust that came from the metal fuel tank. But if it's a plastic fuel tank, it doesn't have any rust. What is the thing catching? Should there be nothing in there? Well, remember when you go to put the fuel nozzle in, there could be a little bit of debris on it, or even when the refinery manufactures the fuel and then puts it on the truck, maybe there's a little something in the tank of the truck because they had to fill it, or maybe when they move the truck and they go and they put it in the ground at the gas station, when the driver's filling the thing, kicks a little pebble in there, like there could be some stuff in there. We're transporting this fuel, it can catch some things. But additionally, the fuel that they manufacture at the refinery, there's still some Remember, that fuel got pumped out of the ground in Saudi Arabia from the sands. There's still some stuff in there, just letting you know. It's pretty clean though, but there's still some stuff in there. And so we need to filter it. Now, the filter on the newer cars is no longer like that, and I'll show you, but we still do need to filter it, right? Then from there, it's going to go to a pulsation damper. That's not on all of them, but it could be. What do you think that means? Especially when we get into the GDI, the gasoline direct injection, the pumping of the fuel can make a sound. The customers, they don't want to hear ticking and tapping and stuff like that. And be like, I hear a tick, I think my engine's no good, right? So we try to silence the fuel. We try to make it quiet. Then we're going to send it to the fuel rail, in this case, rails. There's two. And this fuel rail is going to get charged up with a specific amount of fuel pressure. And the injectors all have access to that fuel. So all the injectors get the same fuel, right? So that's why I'm saying if your fuel pump's bad, it won't cause a misfire on cylinder number one. Cylinder number one's got the same access to the fuel as cylinder 2, 3, 4, 5, 6, 7, and 8, right? So if it's a fuel pump, it's all of them, probably a crank no start. If it's a bad injector right here, that's going to affect just one cylinder, just to give you an overview. How much fuel pressure should this have? I don't know. Let's make it 50. 50 is a good number. What controls the PSI in this fuel rail? Think you can guess? Exactly. So this pressure regulator is just going to be like a diaphragm. You know what that means? It's like a rubber disc and a spring. And if that spring is a 50-pound spring, what happens when the fuel pump makes 51 PSI? It pushes the spring, and that's going to actually vent the excess fuel past the spring. And where are we going to send it? The fuel return. So that's the fuel return pipe. So the fuel return was just for the excess pressure, right? So it was a mechanical, basic fuel pressure regulator. Now I'm going to trash talk this design a little bit. Okay, I'm allowed to do that. This fuel pump, how hard is this fuel pump working? It's working as hard as it can all day long. Just pump as much as you can all the time. What do we do with the stuff that you overpump? We'll just bleed it off and let it go all the way back to the fuel tank. So it was good that they put the fuel pump in the tank, because the fuel pump doesn't want to do a lot of suction, but like it's also like, hey, pump as hard as you can all day long. Like, that fuel pump's had a hard life. So this was old school. If you hear the return style fuel system, this is it, right? You'll see the next design's a little more modern. One thing I'd like to point out is a lot of times this fuel pressure regulator will have a little vacuum line go into it, and the vacuum line indicates how much engine load there is. If your engine's under a lot of load, what do you think you want? More fuel or less fuel? More, because you're like sucking in a lot of air and you're like, we want more power. Remember, power is fuel. The only energy you add to the car is the gas you put in there. And the gas has a certain amount of chemical bonds, and we can extract a limited amount of energy from those bonds. If you want more energy, you need more fuel. We need to break more bonds, right? So under wide open throttle, we can indicate, remember, if you go back to vacuum, we have a lot of vacuum at idle. At wide open throttle, we have basically zero vacuum gauge pressure. And so a lot of times when you have 0 PSI right here, it'll bump up your fuel pressure a bit. Part of the reason I've brought that up is two things. One, I've seen where people try to make their car higher performance by disconnecting the vacuum line and plugging it, and that will technically increase your fuel pressure, yes. Your computer is going to compensate for that and slow your injectors down a little bit, but that's true. The other thing is it's a rubber diaphragm. If a rubber diaphragm tears and a vacuum line goes there, where do you think the fuel goes at the end of the day? Exactly. It'll pull through the diaphragm, get sucked up by the vacuum line, and it'll start adding fuel like in a sneaky way. Okay, so I want you to remember this. It's adding fuel that it wasn't planning to add because you have a tear in the diaphragm, right? So remember, when in the next lesson, when we start talking about air-fuel ratio, that's going to mess up your air-fuel ratio. You want 14.7 to 1, and instead it's like you thought you were getting 1 pound of fuel, but little did you know, we were sucking another pound through the torn diaphragm and the pressure regulator. You're like, why are my numbers off, right? That's part of troubleshooting. Here's the new design. this is going to have a longer lasting fuel pump. Because look, the fuel pump, and there's even newer designs, FYI, but the fuel pump is going to suck up the fuel. It's going to push it up. The fuel pressure regulator, wait a minute, that used to be up here. Now the fuel pressure regulator is right after the pump. So the pump is still kind of working as hard as it can, but rather than pumping it all the way up and around and over and down, it's just like, you know what? If you're at 51 PSI, I'm just going to compress a spring and dump it right back in the tank. It's not having to pump it as far. I would say it's a little easier on the pump. So we've moved the fuel pressure regulator into the fuel pump module, which is like not the control module, but the fuel pump sending unit. We'll call the module now because it's together. It has the regulator too. And then it's going to leave the fuel pump and the tank and go, wait a minute, fuel filter? What the heck is that? Now they're putting the fuel filter in the fuel pump module. A lot of times it's actually down here as part of the sock, right? So back here, you could do your fuel filter. It was on the fuel rail. Up here, do you think you're going to replace that fuel filter? You're going to have to take the tank and the pump out. We don't do those. That's like you leave that filter alone. If the fuel pump goes bad, then it's going to get a filter because it's built into the fuel pump module. Make sense? So old cars, more maintenance for the tech. New cars, no maintenance for the tech. You don't get to do that. That's out of sight, out of mind, okay? Still goes to the pulsation damper, and then again, it goes to both of these fuel rails, and it feeds them both with equal pressure. Where's the return? Yeah, but they'll call this returnless. So it's interesting because the fuel pump return is technically in the fuel pump itself, but like that's not really what we're worried about. So we look at this as, hey, there's no return line, returnless. So if you hear the term returnless fuel system, no biggie, don't sweat it. It's this, that's it. It just doesn't have a return line. There's only one line, and it's just the pressure line. By the time it hits that pressure line, it's already regulated, and it goes to the rail, and it's just going to be chilling at the rail. The rail only get 50 PSI because the regulator was down in the pump, and it only allowed 50 PSI. In a diesel, they'd call it like common rail, right? It's just, I don't know. This is not really complex to me. I thought this was simple. I've seen on the ASE on a number of occasions where it'll say like a returnless fuel system, and people are like, oh, what? It's like, yeah, this is pretty much what everything's had for like 20 years. This is the norm. This is actually a little bit more rare to see because it's old school. This is new school. No biggie. Now, what about the pump? Here's some of those parts we were talking about. Kind of cool to see, right? You've got your actual fuel pump module is here. It's all this assembly. A big old assembly. On the top, you got a plate and some O-rings. Fuel sender gauge assembly. What do you think that is? That's the thing that my friend Diego, the fuel sender gauge assembly. Yeah, that's the one that's bad on that BRZ. So he thought he had gas, but he didn't have gas. The reason he didn't know is because this sensor has failed. So it shows, I don't remember, it shows like full or empty all the time. So if he goes and puts a full tank in, it doesn't change. If he runs it dry, it doesn't change. This isn't working. I suspect it's most likely this literal fuel level sensor, but it could also be the wiring between the fuel tank and the instrument panel. And it could also be the actual gauge on the instrument panel. So like when he said, what do I do? I was kind of like, you know what it really needs? Diagnosis. Because I don't know, you know. But if I was a gambling filler, I'm not. I bet you this is what's bad. These fail a lot. However, sometimes the actual gauge fails. And of course, he lives near me, so there's mice chewing on wires. So I'm not comfortable enough to be like, oh yeah, it needs that fuel level sensor because I didn't make any measurements. I didn't do any tests. I really actually don't know. However, if you do go to test this, it's not that hard. You can actually go in and measure the resistance right here with your meter set on ohms, right? And you can sweep it. And guess what happens when you sweep it? Your resistance changes. So if your resistance doesn't change as you're lowering and raising the fuel level sensor, you're like, hey, this doesn't work. Like it's a variable resistor in here. If you remember, if you go back to throttle position sensor, This thing works the same. It gives a 5-volt reference into ground, and the signal wire is going to change between about a 0.5 volt and 4.5, depending on if it's full. Maybe a 0.5 volt is almost empty, and the 4.5 is like almost full, right? So you could just sweep it. It's an easy test, except it's in the fuel tank. So it's kind of like, yeah, dude, I could fix it, but it's not really gonna be cheap. Minimum diagnosis for that. I don't even know if I'd diagnose it for an hour. I'd probably tell them like, I'm gonna diagnose it, but you need to basically be prepared to fix it. And when I get in there and I do the diagnosis, we'll put that towards the repair because I already have to have it apart somewhat. Make sense? How can you sweep the arm if you can't get access? Now, here's the good news. What I was saying about removing the fuel tank, a lot of times, they'll put an access panel in the top. So if that fuel tank is under the back seat, sometimes you remove the back seat and there's an access panel. That one wouldn't be all that hard to diagnose the fuel level sensor. But sometimes they're hard and sometimes they're not. And sometimes there's an access panel and sometimes there's not. And if you ask my dad on his Blazer, if there's no access panel, there's about to be. You picking up what I'm putting down? There's an access panel now, but the only thing is if you're going to cut it, you're cutting it with an abrasive like a cutoff wheel and you're throwing sparks all over that fuel tank. Hope you don't have any leaks, especially if it's a metal tank that's kind of like corroded and it's got pinholes. You may have what the manufacturer would call a thermal event. All right, makes sense. So good overview. And then this whole plastic housing. This actually has a fuel filter built into the top. Sometimes the fuel filter's here, and sometimes it's really only down here. Sometimes it has both, but we call a lot of times this is the sock. It looks kind of like a sock or the fuel pickup. And then what's kind of interesting is like when you slosh it around, a lot of times fuel will slosh into the sending unit, and then this sock kind of sticks out the bottom. So it has a couple ways to pull the fuel. I've even seen where customer will bring in the car for a crank no start, and if the fuel level shows low, I don't know if it's a bad pump or if it's low on fuel, I'll literally grab the vehicle and I'll rock it like this, like rock it, and then boom, if all of a sudden it fires up for a couple seconds and then dies, it's like, hey, you're just low on fuel. Me sloshing it around may get a little bit of fuel to get sucked up by the sock or even end up. It can too, yeah. If you have a bunch of garbage in the sock, sometimes shaking it and having a little bit of stuff pop off of it, it'll fire up. But then when it starts sucking fuel up, it'll reclog it. That's true too. So then it'd be like, well, let's try to add a few gallons. And if a few gallons, it still does the same thing. No, we're going to have to pull the pump. And then when you pull the pump, we'll show this next page, you're probably going to end up having to do a full fuel tank clean. So like this would be on a rear wheel drive. This is where the drive shaft would go. These fuel tanks can be kind of complicated. Sometimes they actually have a pickup tube that goes over to the other side. And so it'll pull fuel from this side and from that side. They get a little bit complicated, but the truth is, by the time the fuel pump has failed, more than likely, there's been so much fuel put into that tank. Remember, there's little contaminants from the refinery and from transport and stuff. You probably need to do a full clean of the inside of that tank. So they do make little special brushes to clean the tank all up, right? So like you could slam a fuel pump in there, something I've done many times, but if you still have small particulate and debris in the tank, how do you think your new fuel pump's going to like that? Probably not going to be real happy pulling particles through the high-speed fuel pump and motor, right? So be better to like clean the tank extensively and do the fuel pump in there, and that's going to be pricey. It just is what it is. And then again, like most of these are going to be jet pumps, so they don't really like to have this type of suction pipe, but sometimes they may need to. It's better if it's fully submerged. I'm for a number of reasons, but if it's a jet pump, it's going to basically be immersed in it and it's going to send it up. Sometimes these will actually have two fuel pumps. And sometimes they'll have a fuel pump on one side, but they'll need a sending unit on the other side to measure how much fuel is in the other side. These types of complex shaped fuel tanks kind of suck, to be honest, but it is what it is. Okay, and then if we were to get into, I think we're probably pretty good on there, but I believe I made a note about, it might come up again, but in the case that I missed my note, there was something I wanted to say. When we pull fuel right here, we're going to pull fuel up and we're going to send it out the pump. The thing is, when you shut the engine off, the fuel pump and tank sit low. So you could have all this fuel drain back, right? It'll drain back and go into the tank. What's going to happen when you go to start it next time if it all drains back? It's going to take a while, huh? You're going to be like, shana na 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 na, and the fuel's like, I'm getting pumped out, but I got to make it all the way up the line, 15 feet to the engine. That's going to take time. So what we do, we put in here a drain back valve, a fuel anti-drain back valve. I know I've got a picture of it, but I just want to point it out while it's very visual. We put a valve in there so that when you shut the car off, that one-way check valve will hold the fuel primed. And if that check valve is bad, what do you think the customer symptoms would be? Extended crank, especially after it sits for a while. So if you were to run it, shut it off, and start it right back up, it'll start quick. But if you were to shut it off and wait an hour and then crank it, it's going to be because the fuel had to make it all the way up there, right? So how do we replace that? That's in the fuel pump sending unit module assembly.
You can test that by like turning the key on and off a few times, right?
The way that I would test it is I would put a fuel gauge on it. I would turn the key on. Let's say it pumps the fuel gauge up to 50 PSI because that's where the regulator is. Then I would turn it off. I would walk away. I'd go do my work and I'd come back in 5, 10, 30 minutes and I'd see, is it still pretty close to 50? If it's down to 9 PSI, I'd be like, oh, that's draining back. It's an anti-drain back valve. It's a one-way check valve. It should allow fuel out, but it shouldn't allow fuel back in. Yeah, so it's a pretty easy test. And again, because this class is all about not just parts canon, it's about diagnosis. Like that's a good, clean, legitimate diagnosis. You measured it before, you measured it after, you're like, boom, I confirmed it. Again, when you're thinking of diagnosis, you prove it. You want to prove that that's the defect, not just be like, well, it could be, and I think it's a good idea that you change your fuel pump. It's like, is that what's wrong or not? You'd be like, there's only one way to know. We got to spend $600 and put it in and then find out. And it's like, fuel pressure gauge will diagnose the whole thing in a half an hour. Like that's better. That's a better service for the customer. If you get good at it, you're worth a lot of money. I'll be the first to admit. And I can tell you, there's lines and lines of people who want to hire somebody who can do that type of work, just so you know. Yeah. Okay, now moving into some more of the control side. What turns the fuel pump on and off is typically going to be a fuel pump relay. Now, sometimes they have another thing I wanted to point out. Like if it's a relay, the PCM will control the relay, but the fuel pump draws a lot of amps, you know, like 10, 15, maybe even closer to 20 amps. The PCM doesn't want to handle 15 or 20 amps. The PCM can turn on and off a relay, and the relay will handle the 15 or 20 amps to run the pump. Okay, so typically the relay controls it, just so everybody's all clear. Additionally, sometimes there's what's called an inertia switch, and an inertia switch is back in the day. I'm going to pick on Ford right now because I can, but back in the day, these Fords were having issues where they would get hit, like they get rear-ended in an accident and the fuel pump would keep pumping. And next thing you know, like if you're in an accident, you might rupture a fuel line and the fuel pump would keep pumping, right? Because when you get in an accident and you're like kind of shell-shocked, the first thing you do is not like, oh, turn the ignition off so that way the fuel pump doesn't run. Like they don't think about that. They're just like, oh my gosh, I don't know. The fuel pump keeps pumping. And then all of a sudden there's fuel all over the place. And the hot exhaust and, you know, sparks and things, bad things were happening. So they came up with this thing called an inertia switch. And basically the inertia switch is a device that if you get hit hard enough, it'll make inertia. It'll actually set this inertia switch, which will kill the fuel pump. So it's kind of crazy. Like you'd get in an accident, boom, and then you'd fix all the body damage and it still wouldn't start. And then they tow it to the shop and be like, yeah, that's got an inertia switch. It's a Crown Vic. Like push the inertia switch, click, boom, and that would let the fuel pump fire up. They're not doing too much of that anymore. Now that it's computer controlled, you know that your your airbag, your SRS module, supplemental restraint system computer will say like on the network, like, hey, we just got hit. Like shut off deploy the airbags first. And then secondly, don't tell the fuel pump to come on anymore. So now we can do it electronically, like with the computer. But back in the day, we had an inertia switch that was mechanical and it would actually it would trip it. And so it's just kind of fun. But now we're mostly all electronics and we're using this relay. The relay is going to be computer controlled generally on the newer one. And then you guys can see, like, if you start to diagnose a fuel pump issue and your fuel pump's not working, just because the fuel pump doesn't work, does not mean that the fuel pump is the problem. The fuel pump needs 12 volts and needs ground. If the fuel pump's not getting 12 volts and ground, you got to study the wiring diagram. You got to trace it, right? This is kind of like A6 applied to A8 material. It's not complicated, right? Being able to see like, oh, here's the relay, and the relay gets 12 volts all the time, and the relay gets ground from the PCM. And then when it gets ground, it's going to magnetize the relay, move it over, and send voltage to the fuel pump. Like if the fuel pump doesn't work, you can troubleshoot at the relay pretty well. And the meter is the main go-to if you know the fuel pump doesn't work. But if we back up, how did you know the fuel pump didn't work though? If it did a sha-na-na, that could be no spark, it could be no fuel, it could be no compression. True. If it's if it's going into like an anti-theft, like an immobilizer mode, it'll turn the injectors off because it thinks it's being stolen, right? So we can't just jump to, oh, it's a bad fuel pump. If it's got a symptom of a bad fuel pump, like the crank no start, and then let's say we put a fuel pressure gauge on it, which I'll show you, and it makes 0 PSI of fuel pressure, you'd be like, hey, I don't think the pump is running. You could actually listen down in that fuel filler neck and be like, hey, go to crank it for a quick second, just bump the key to crank for a second, and you should hear, or if you keep cranking it, you should hear, and you listen like, I don't hear a thing. You could use a stethoscope. If your fuel pump's not running, yeah, it's probably time to check to make sure it's getting 12 volts in ground to run. If it's getting 12 volts in ground, but it's not running, the fuel pump motor is bad, which we're probably going to do the pump assembly, the whole module. If it's not getting 12 volts, then we need to look in the diagram and trace it just like a headlight in op, right? Same tools, same idea, you know, same test procedures. Now we'll get into more of a modern one. A modern fuel pump, which is going to be variable. They'll call that fuel pump modulation. So fuel pump modulation means we'll turn it on, we'll turn it off, we'll speed it up, we'll slow it down, right? So when we were looking at that old picture, the first fuel pump was pumping as much as it could, all the way up to the engine and all the way in the return. That was hard on it. Then we're like, you know what? We'll just have it dump the return off early. That was a little easier, but it's still pumping as hard as it can. A modern system with the variable fuel pump, a lot of times we're going to control it with pulse width modulation or duty cycle. We're going to turn that pump on and off. We're going to say like turn on for 50% and then turn off for 50%, because that's all you need to do to make 50 PSI. You think that fuel pump appreciates that 50% break? It's not working 100% of the time. It's working 50. That's going to prolong the life of the pump, right? But there's a little bit more to it than that. Now we don't need to do much, if any, fuel pressure regulator stuff. If we have a fuel pressure sensor and we're targeting 50 PSI, and let's say we only have 40, do you know what we need to do to the pump? Turn it on a little bit more or speed it up. And then if we get to 60 PSI, be like, whoa, take a break, like turn it off a little bit longer or slow it down, right? So we have modern fuel pumps that are not on and off. They're speed up, they're slow down, they're pulsed on and off, like through pulse width or duty cycle. And that's good, that's good. But what about for the technician? You used to go back there, if you wanted to on the old system, you could go back there with a test light. Does the test light light up at the fuel pump? Yes. Does the fuel pump work? No, fuel pump's bad. Test light. You could do that with a meter, a little more modern. You put does it have 12 volts in ground? Yes. Does it work? No, fuel pump. Now it's like, what signal is the fuel pump getting? Did you catch that? It's not getting just 12 volts, it's getting pulses. So if it's getting a pulse width modulation, we need to verify, like, is it getting the right pulse? Do you think That's going to be a little tougher. I mean,
Put a scope on it.
the scope is actually a really good diagnosis tool for the fuel pump now. You can see the waveform and see, is it getting an on signal and an off signal, an on signal and an off signal. So it's like even this modulated fuel pump diagnosis is going to be a little more tricky, right? That's kind of the point. What is giving the on and off signal though?
Modules.
Yeah, it's going to have a lot of times a fuel pump control module. Sometimes the PCM could do it or the ECM, but a lot of times we'll have a fuel pump control module and the ECM or PCM will send out a command to the fuel pump control module. Hey, we want like this much fuel pressure. And the fuel pump control module will be like, oh, okay. That's like a 50% duty cycle. Do half on, half off. Oh, you want more? 60% on, 40% off, right? So the fuel pump control module now does that. That's gotten a bit harder to diagnose. Now you got to make sure the fuel pump control module is getting what it needs and that it's putting out what it needs. So if your fuel pump isn't running on one with a fuel pump control module, you got to determine, is it the control module computer or is it the actual pump? And sometimes to do that, we got to look for a waveform, right? It's a little more tricky. But just so you're aware, we'll see what we can do to get one up on a picoscope or something. Cool. And a little cheat trick. Nice high-end meters like a Fluke 88V actually have a PWM or a duty cycle setting. So you can act like you're checking voltage for 12 volts, right? But instead you put it over on duty cycle and it'll give you a percentage. And if it says 50% or 30% or 80% or whatever you think the number is, you'd be like, oh, it is getting it. So there is a way to test it without the picoscope, but it's depends on your meter and it's a little vague, but it's most of the time good enough. If you're expecting your fuel pump to be at 50% and you use your meter on duty cycle and it says 0%, you know you're not getting a signal out of the fuel pump control module. Cool, so it got a little complicated there, but it's okay. Alrighty. Oh, and I knew I had a little note right here about the check valve. The check valve in the fuel pump keeps the system under pressure for a period of time, right? So it's there. Then when we get into the actual pump, like some of this stuff won't be extremely critical, but so you know, all the pumps have a mechanical and an electrical aspect. Very good about service info. So if we have the fuel pump is actually the part that moves the gas. It's the pump. It's like the fluid pump. But that pump is going to be connected. See, like this pump and this pump is going to be connected to a motor, which that's going to have like starter motor, window motor, you know, any RC car motor type of components. It's going to have, let's say it's probably like, maybe it's brushless, but it's going to have all the electrical components like an armature and maybe even a commutator and brushes. Or if it's brushless, it's going to be like an electronically commutated, maybe permanent magnet. But all the motor parts are motor parts. So if you have a fuel pump where the motor fails, it probably won't turn. I've also seen a fuel pump where one segment or two segments in the motor fail. And at that point, it'll turn, but it'll be like fast and then slow and then fast and then slow. If your electric motor can't keep the RPM you want, do you think it's going to make the fuel pressure that you want? No, exactly. So if for the most part you wouldn't need to, but like if you got a weird issue where it's not making correct fuel pressure, you can actually scope this motor for the fuel pump and you can look at the waveform and give like a really detailed diagnosis of what's going on with that fuel pump motor. I just don't do that unless I need to. So I'll give you one example. I'll even share you the video of why I needed to. It was happening in my own motorcycle a couple motorcycles ago, which has an electric fuel pump in the tank just like this. Same thing. Once a month or so, it would blow the fuel pump fuse. Why do fuses blow? You guys would know. Sounds like a short or something, right? I looked all over the whole wire harness. There's nothing touching. There's nothing chewed. There's no bare wires that are like periodically arcing to the frame and grounding and shorting. So I was like so confused. It's like, why am I getting an intermittent fuse blow? And so after the harness checked out, it was like, you know what? Maybe there's a problem with the fuel pump. So I did hook it up to a picoscope and I was able to graph it. And I believe it had eight segments in the motor. And on 6 or 7 of them, they looked clean. And then on like 1 or 2 of them, it was kind of flat. So I actually had, it's almost like a V8 running on 6 cylinders. The problem was that fuel pump would speed up and then it would get to the dead segment and it would slow down. And then if you ever notice, like with a drill, a cordless drill, you ever grab it and squeeze the trigger and you notice it struggles? Like the light will dim and stuff like that. When you're trying to move a motor from a stop, it draws a lot more amps. Every rotation, my motor was trying to get itself moving after the dead segments. It would draw more amps. It was periodically blowing the fuse once in a while, depending on when I started the bike, if it got stuck on the dead segments. It was a really interesting diagnosis. Normally, it's not that complicated. It doesn't work. You know that the motor is bad because it gets 12 volts in ground. That's it. Once in a great while, it could be a complicated one, like that one. But wait, there's more. What if your motor is healthy, but you've got wear on this gear rotor, or if it's some kind of a like a sliding vane type of pump? What if you have mechanical wear on the pump and it's bleeding pressure internally and it's not able to put out all the fuel it sucks in? You think that's going to have an effect on your fuel pressure? Yeah, so it could be the electrical part or it could be the mechanical part. You want the good news? They come together. It's like, you're not going to be like, let me get the fuel pump motor and let me put the wet end pump part on the new motor. Like, you're doing both. They come together. All you got to be able to verify is the fuel pump getting the voltage it should get, and is it making the pressure it should make? Like in my case, it wasn't an issue of the voltage or the pressure. Mine was blowing the fuse, which is kind of abnormal. Right? And I've only ever had one in my whole life. I've seen a lot of weird stuff. So typically the fuel pump should be turned around 7,000 RPM. On the scope, if you were to picoscope this into a waveform and look at the times, you can actually calculate the fuel pump RPM, but that'd be like way geeked out, excessive diagnosis 99.9% of the time. But if it's an unfixable thing that no one can figure out what's wrong, just know you can. You can tell what the RPM is. Okay, let's say we're going to do a fuel pressure test. This is like a spark test. Like a spark test is critical. You need to do this like immediately diagnosing the car. Fuel pressure, same thing. Look up the spec. Then you got to find out where you got to connect it. So some places vary. So like this one, if you see this little gold valve right here, this is on the rail. And this little valve, it kind of looks like where you'd set tire pressure or where you'd hook up AC gauges or something. There's a special type of fuel gauge connection. And we're literally just going to screw our fuel gauge in and then turn the key on and look at the gauge. It's really easy on this one. Not all of them have that, right? So on your fuel rail, like later today, you're going to see a valve like that. We're just going to hook fuel pressure gauges up. Super easy. What's the spec? I don't know. It depends. And then I made a little note here just to make sure everybody understands. This is for like a port fuel injection system or even throttle body injection. But if it's a gasoline direct injection, you won't find that test port because your gasoline direct injections running 4,000 PSI, and that's going to explode your gauge. So if it's GDI, which we cover at the very end, we don't check fuel pressure this way. We're actually going to check it through the fuel rail pressure sensor. If it has a fuel pressure sensor, we don't even really need the gauge. But a lot of times they don't if they're a little bit older. Cool, so we just hook the gauge up and check the pressure just like it's a tire. So here we are, hooking up the gauge there. It's easy. And then we're going to read it. What's this one read? Let's see, 20, 40. Well, first off, in here is KPA. Those are not freedom units. We want PSI. Those are freedom units. So 20, that number is going to be 30. That's 40. So we're about like 31 PSI. What if the spec was 50? Is this good or bad? Spec is 50. It's only got 30.
It's gas savings.
Well, and power loss as well. So if the car doesn't start, what do you expect your fuel pressure to be if it won't run at all?
0.
Pretty much 0. I agree. So if you're doing a no start and you got 30 PSI, I'd be like, I don't know, that's kind of low, but I don't think that's not causing the no start. But what if you have a car and it's got a loss of power under heavy acceleration? This would make sense.
I see it now on the acceleration.
True, and it would lose a ton of power too. Yeah. So you'd be like wide open, brr, and it'd be like, oh, because it's pulling in air, but it can't match it with the fuel. So that's not going to make enough power. It's going to be loss of power. This would make perfect sense. I've even seen where it makes 50 psi at idle, but then when you slap the gas pedal, the go pedal, and the injectors are like, yeah, like freedom, like, and then the fuel pump's like, wait a minute, I can't pump that much. Like I'm good with idle, but at wide open, it's just running out of juice. That fuel pressure gauge will go from clean 50 to all of a sudden 30 under wide open. That fuel pump can't keep up. That'd be a good diagnosis of a fuel pump. See what I'm saying? So it can vary. I've also seen where the fuel pump has a problem with the motor, where everything is cool and everything is good, but then once in a while the car will die. You'd be driving, and then all of a sudden stumble, die. You're like, did the fuel pump just die out? How would you know? Hook the fuel pressure gauge up to it, tuck it up under the hood, tape it to the windshield, drive around. If the car stumbles and stalls and you look and your pressure's still 50 psi, it wasn't the fuel pump. But if you start to see your fuel pressure dropping and it's correlating with the stumbling and then ultimately the stalling when it hits zero, you'd be like, oh yeah, it lost fuel pressure. Now the question is it electrically the fuel pump itself? Or could it be a wire going to the fuel pump or like the relay that powers the fuel pump? Then you're just diagnosing an electrical problem, right? So sometimes these drivability and engine performance problems are some of the more complex. But if you can understand it, you could definitely fix it. But it is a bit of a more challenging subject, right? So another thing that we'll do that's not part of this is I'll measure the fuel pressure. And sometimes what I'll do is I'll get like a little can or like a water bottle, a Gatorade bottle, and I'll squeeze this little button right there. You guys can see that button. That's going to relieve your fuel pressure. I'll squeeze that and that'll really tell me how much it's flowing. There's been times where I squeeze this little button and this drain hose, like just a little bit of fuel come out and be like, that's not a lot of volume. It's a lot of pressure, but not a lot of volume. When I squeeze this, it should like fill that Gatorade bottle within a few seconds. It should be quick, right? So I'm just testing the pump thoroughly, right? So let's say we're working on our pump. Here's the sock. If this thing was all full of stuff, what do you think the symptom would be?
Low volume.
Low volume, exactly. See, I could test that with the gauge. What do you think the customer's concern would be? Low power on heavy acceleration. It might idle good. If you accelerate a little, it's good. But if you punch it wide open, it's like, I don't have enough gas. You see what I'm saying? So when you don't have enough gas, you're like, is it the fuel pump electrically? Is it the maybe it's the sock? But either way, guess what? If you're getting a fuel pump, it comes with the sock. Yeah. So you would have diagnosed it well, and then you pull out and be like, oh yeah, the sock is all full of stuff. If the sock is all nasty, you better clean the tank too, though. And then you might talk to the customer and be like, hey, did you dig this fuel out of the ground and shovel it into your car? Or like, where'd all this debris come from? You know what I'm saying? Because you don't really want that in there. The sock has a limit to how much debris it can catch. Cool. And then different types of modules, right? So this one's pretty typical. You can see the fuel level sensor. You can see how the fuel level sensor has this piece of plastic we call the float. For some reason, if the float had a hole, it will no longer float. It might give you the appearance of your electrical failure, but actually it could literally be a hole in the float. The good thing is if you get a new fuel level sensor, it comes with the float and the rod and the actual sensor right here, which is a variable resistor grid, like a carbon grid. Cool. But there's another part that may or may not come with the pump. It's right there. It's in black. That's your fuel tank pressure sensor. That's not really for your fuel pump. That's more for your evaporative emissions. Sometimes you can get the sensor separate, but if you had a problem with the fuel tank pressure sensor, just know it's typically right in the top of that pump, like what we saw right there. I'd still say it's fuel system. Then, of course, we got fuel lines that are going to go up to the system. These are the fuel lines. What do you think this silver stuff is? Give you a clue. It's got to do with this rubber thing and this thing. Is it just me, or does that look like an exhaust hanger? So if we got fuel lines near the exhaust, is that sketchy? It's normal, sadly. I mean, I'm a little scared, but we run a protective heat shield around the fuel lines to keep it from getting the fuel too hot, to keep vapor lock. If your fuel boils, it'll become a vapor and then it won't start, but also keep it safer. Safer, more better. Cool. And then of course we got fuel filters that can look like this. This was old school. We used to do these fuel filters all the time. Ron knows about these fuel filters. Be cracking that fuel filter loose and you'd be working on it like this. By the time you crack it loose and the fuel's still in the lines, all the fuel's going to go down your line, down your wrench, down your arm, and right into, you're going to feel it when it gets in this area. You'd be like, ow, I'm burning. Oh yeah, yeah. And so sometimes what you need to do is learn to work like this. Like you got to make a drip location so it'll drip off your elbow, right? So this wasn't like amazing work. Like we all did it, but it was never like, oh yay, I get to do a fuel filter. It was like we were doing these fuel filters like 30,000 or sometimes less miles. Yeah. So like a 30K service would be like air filter, cabin air filter, oil change, spark plug wires, cap rotor, fuel filter, like a pretty big major maintenance. Oh, definitely. That was just back in the day. This is what we were doing. These were kind of junk. And the thing is, if this fuel filter was clogged up, it would give us the fuel starvation. If this fuel filter was clogged up and you didn't change it, it would put excess strain on the pump and it could cause your pump to fail prematurely. So if you were to roll into O'Reilly's, they'd be like, oh, you need a fuel pump? You really should get the filter. And you're like, why? They'd be like, oh, the filter causes the pump to wear out. And that could be true. And then you change the filter and be like, oh, now it's quiet. No, it's true. Those are fun times. It's just old school. But on a newer one, you got a sock that's got like this is like the Snap-on tool truck socks. Those are the nicest, softest socks you'll ever see. They're really hot though, but they're very cushy, very thick. They got a lot of material. You probably need like a half a size up on your shoes because they're thick. Okay, that's a lifetime fuel sock right there. So when they say like, oh, the fuel filter's non-serviceable, the fuel filter's lifetime, it's probably something like this. That's going to last the lifetime of the pump. So we don't do those anymore. Fuel filter services are mostly gone, unless it's old school. Okay, it's just the way it is. Cool. And then if it's broken apart like this, you can see a lot of times fuel is going to come in, going to have to go through this type of a thing. That's just like the fuel sock. You know, there's going to be a paper filter or some kind of fabric. There's going to be some sort of a filter and it'll filter down to a certain amount of microns. But like if you're in more of a fleet application, specifically with diesels, a lot of times they'll have like a spin-on filter that's real easy to do, and they'll be doing those a lot more often because that diesel tends to have even more sediment in it, right? So this is really a gasoline filter. The diesel ones tend to be bigger and spin-ons, kind of nice. But similar, they have media in there. All right, if we're into a fuel filter, why is it needed? Maybe because it's due on the miles, right? So if you want to sell a customer something, you got to have a reason. Why are you going to sell spark plugs? Maybe they're due on mileage. Same with a fuel filter. Maybe you're selling spark plugs because you took them out, inspected them, and the gap was off. Maybe you're selling spark plugs because you diagnosed that it's part of their misfire, right? Same with a fuel filter. You don't just sell the fuel filter because, right? So if it's due, sell it. If it's got a low fuel pressure concern and you've diagnosed it as a fuel filter, sell it. Makes sense? But like a lot of times back in the day, like my dad would always be blaming the fuel filter for everything. Be like, oh, it needs a new fuel filter. And I was kind of like, your Blazer is like stumbling intermittently. He's like, yeah, I think there's some junk in the fuel filter. Like, could it be anything other than the fuel filter? I think it's the fuel filter because if I punch it, all of a sudden it'll clear out and go. And I was sort of like, yeah, but if it was the fuel filter, it would run worse at wide open throttle. And he'd be like, yeah, it's junk in the fuel filter. Guess what? It wasn't junk in the fuel filter. It was a worn distributor shaft. And periodically the distributor shaft would move and it wouldn't make contact and it would lose spark. And then all of a sudden it would move back and it would get spark, right? So just my personal addition, people blame the fuel filter for too much. They're doing too much. Is that put into context right? Fuel filter, fuel filter, fuel filter. Like, no, chill. That's not the problem. Let's look at some other things besides the fuel filter. Okay, makes sense. And then it's going to give you some specs like how do you depressurize it? How do you access it? Sometimes you need special release tools down here. Sometimes a good mechanic will put a date on there. Sometimes for my friends, I write little notes on there. And so that I even years after I left the dealer, I got a message from a friend be like, hey, I'm doing your fuel filter. And I'm like, you know, we do fun things. We do with oil filters too sometimes because we can. But this may actually need a special fuel line release tool. Sounds kind of a hassle. Put the drain bucket, you know, sometimes we'll even disable the fuel pump, but I don't really see any particular reason. I'm just popping it off there. I'm going to let it drain. I'm going to try to do it fast. Not a real big deal. All right, but what if we're going to do a thing with the fuel rail? See this little fuel rail? This is, I think, on a Subaru, I believe. Here you got the fuel rail. That's the fuel pressure regulator. Got a couple of injectors. Why would we pull a fuel rail? It's probably really to do an injector. Fuel rails typically don't fail. But if we need to do an injector, the injector is like stuck between the engine, probably the intake manifold, and the fuel rail. The fuel rail pushes it down. There's an O-ring here. There's an O-ring down here. This O-ring seals the intake port from outside air. So if you look at this lower O-ring, if this lower O-ring was failed, it would be sucking air in past the O-ring. That's going to throw off our fuel trim numbers, stuff we cover next time. What do you think if it was the upper O-ring where the injector seats into the rail? What if that upper O-ring was messed up? It leak what? Okay, and that's scary. All right, so true story. I worked with a dude. He came through the same program as me, but honestly, he was always kind of like, I don't know. He was just never locked in. Okay, I'm getting all the Gen Z terms today. He's never really locked in. He's always kind of like his mind someplace else. Well, he got promoted. He was a year ahead of me. He got promoted a little before me. And I specifically recall a car came back on a tow truck, burnt, like on fire, like burnt, scary. And he had just done some with the fuel rail. He got fired and he had kind of had it coming. If you take this apart and that fuel and that O-ring tears or gets rolled off or something, you'll have a fuel leak onto these parts that could catch on fire. So if you go to get involved in these, you got to be very aware that upper O-ring that sticks into the fuel rail can't be ripped, can't be rolled. I like to use a silicone paste, and that'll really like lube the O-ring well. And when you go to pop the injector in and it's like the right grease is on there, it fits just right. You can tell it feels good. If you're forcing it on, you're a lot of times the O-ring starting to roll out of the groove. That's a scary thing. He did two things. He messed it up an O-ring, but also where the fuel line was, like back here, you notice there's this little clip that we pulled off right there. That's like a safety clip to make sure it's clipped in all the way. He couldn't get it back on, so he threw it out. Do you know why he couldn't get it back on? Because it wasn't clipped in all the way. That's exactly why it's there. So he's like, well, just discard with that. So I'm saying it's partially my job for you guys to understand when they have those clips, when they have these O-rings, like you got to have your wits about you. You know, you got to be paying attention. You got to be locked in, because if you end up with a fuel leak and that catches on fire, firing was actually probably the best outcome. The worst would have been kind of similar to what happened on that freeway with that thing in Ontario. You know, three people are dead. 3 people are dead. I mean, you could kill somebody. You understand? You could literally kill somebody if this O-ring didn't seat right. That car could catch. So this is a serious thing. If you're working fast food, it's like, I guess technically you could kill somebody, but more than likely you forgot to do no pickles and they come back like, I got pickles, you put pickles on my thing. And you're just like, fine, I'll just give you another one. Like, here's another burger. Like, this is different, you know? So that's part of the reason that to do this type of work, you're going to get paid a lot more. There's more, you have to have a lot more skill, a lot more liability. You screw up, people have more to worry about than you put pickles when they said no pickles. You know, I'll take the pickles though. Like, I'll eat the pickles, and they'll be like, no pickles on the next one, but I'm taking those. Matter of fact, I might just down, and here you go, we're good to go. Probably not going to take that. So serious stuff though, okay? Funny, but serious. He got fired. Okay, so this kind of just shows like when we test the fuel pressure, we're testing at the rail. The rail should be pressurized to whatever this is, 30, 40, 50 PSI, whatever it is. That's why those O-rings are a little scary. There's 50 PSI of fuel behind them. They have a little tear, there's going to be fuel spraying. It's probably going to be fine and atomized, perfect for catching on fire. Cool. So that was a nice overview of the whole system. You put in your gas here, the go-go juice goes down here, the fuel pump is submerged. It's going to use a sock to initially filter it, send it over to potentially a filter, and or there may be a fuel pressure regulator which may recirculate it back, or depends on the system. Maybe this fuel pump is a variable speed fuel pump, variable displacement, variable demand. That's a fuel pump control module that's going to fine tune the RPM and or the on-off time, right? Go up to the injectors, and the injectors are going to be one of the next things we cover, but those are going to be controlled by the PCM. Cool. So it's pretty good. And then overall, kind of similar. Like if you look, this one would have a return line coming off of here, but normally the regulator's up high. This one actually has a fuel pressure sensor, so that's really nice. To be honest, if it's got a fuel pressure sensor, you probably don't need the gauge. How would you check the fuel pressure if it has a fuel pressure sensor? Think back to the tools we use. It's got a fuel pressure sensor. How would you read it? Scan tool it. That's what I'm all about it. I'd be like, I'm not even getting the gauge out. Let me check the fuel pressure on the scan tool. Oh yeah, 30 PSI. Yeah, exactly. Live data. That's a parameter ID, a PID. That's nice, right? So kind of similar. And this just kind of like a little bit of review. Remember, it has the vacuum line, and this has a mechanical fuel pressure regulator and the whole return line. That was a good shot of that whole system functioning. This is going to be more current, where it's got the fuel pressure regulator down in the pump. And then fuel pressure regulators can be different types. So vacuum's common. If this one rips, you'll have fuel in that vacuum line. Probably that's the most important one to be worried about. Go ahead.
Most cars have fuel pressure sensors.
Sadly, no. No. If it's direct injection, absolutely. If it's port fuel injected, probably not. Like let's say we look at this fuel pressure sensor. Do you see how it's right in the rail? That costs a little bit of money to do. And it also, this is a pressure transducer. So that's going to measure pressure and make it into an electrical signal and send it to the ECM. So like there's a cost there. Ford likes to use those. And any car that has gasoline direct injection will have it. But for example, I'm actually good with knocking my own brand here. The domestics are good about putting fuel pressure test ports on the fuel rail so you could easily connect a gauge. But the Japanese, I don't really understand their problem sometimes. Like they're like, they're really good at some things, but like I used to joke around with one of the Toyota corporate trainers, and he'd be like, every Christmas we ask the Japanese engineers to give us a fuel pressure test port on the fuel rail, and every year they never get us what we want. So I don't know. The Japanese, for some reason, don't believe in those test ports. So if you wanted to check fuel pressure on a Honda, Toyota, Subaru, most Mazdas, the new Mazdas, not the old Mazdas, you actually have to disconnect the fuel line, put in a T, reconnect the T to the fuel rail, reconnect the fuel line to the T, and then your gauge would attach to the T, and then you could check it. But by then you spent like a bunch of time and adapters and goofing around. It's like really irritating. So you get no fuel pressure test point, and you get no fuel pressure sensor. You got to use T's and adapters and stuff. It's pretty irritating. Okay. Whew, I'm done. I don't know. Hey, ask them. Ask them. Hey, for Christmas this year, can we have a fuel pressure test point? You've been waiting a lot of years. All right, but so this is nice because you can just scan tool it. I do like that. We'll see when we get over there because you guys are going to find out. All right, and then injectors, I think we could go wild into all the details, but I think you'll get the important points. The injector's job, it gets fuel pressure into the top. That's where it gets its fuel. In the top, typically there's a little screen. Why do you think there's a fine screen right there? Exactly, and it does sometimes catch stuff. So I had a homie with the Neon. You guys remember those? A Dodge Neon. Junk. Yeah, it was junk then. It was junk when you had it. It was junk when he had it. like every 3 months or so, he'd end up with a horrible misfires. And every 3 months or so, we'd pull the fuel rail out, take the injectors, tap them upside down, and rust would come out of the top of that screen. How it was making it past the fuel filter, I don't really know. Maybe it was the inside of the fuel line. I'm not really sure, but we cleaned it all out. And like literally every 3 months, he kept cleaning them, putting them back in. And then eventually those O-rings ripped. So it ended up with a fuel leak. And then it was his dad's like, David, you can't drive that car till you fix the fuel leak. And he's like, well, it still works. And it's like literally there's fuel spraying out. It's kind of scary. At the time, it didn't seem that bad. But when you're young, you don't really know that much. Got a lot of ambition though. And so it was like, no, you need to go get him. His fuel injector O-rings were special order. It was a whole big old nightmare, but those screens can get clogged up. That does happen. That's what the filter screen is. But if the fuel makes it past there, it goes into this passage, right? And it goes down this passage. It's going to get stuck right here at a needle valve, or sometimes they'll call it a pintle, right? So that fuel injector won't pass fuel. Make sense? It's sealed. It's almost like it's like a V is the seat, and the needle seals against the seat, and the fuel's there. But do you know how we make it flow? We have to unseat the needle. We have to unseat what here it's talking about the needle valve. How do we do that? We have to pull it back. How do we pull it back? Anybody think they know? Electromagnetism. If we give this injector 12 volts in ground, it's going to magnetize this electromagnetic coil. It's going to pull on this iron core. It's going to pull it back. Then that's going to unseat, and fuel will make it past the needle and seat, and it'll spray. It's pretty simple, right? You give an injector 12 volts in ground, it clicks, and that opens the valve, and the fuel sprays. But to precisely meter it, which is mostly next lesson, we're going to pulse it on and off. So injectors, they go tick, 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 tick. We're pulsing them on and off. If you want more fuel, we're going to pulse them on more, and we're going to pulse them off less. If you want less fuel, we're going to pulse them on less, and we're going to pulse them off more. Make sense? So by default, the injector has a spring, and it should seal this needle up against the seat, and zero fuel should spray. So if we had an injector that had the harness cut to it, what's that injector going to do? It's going to be seated. So is there going to be any fuel spray? No. So if that injector is not getting 12 volts in ground, it doesn't spray any fuel. Make sense? What if for some reason the injector needle and seat got kind of messed up and it wouldn't seat all the way and it was leaking? What would happen? Spray way too much. It would spray all the time. As soon as you start the car up, it's just spraying and spraying and spraying. That's going to have way too much fuel in that cylinder. That could cause a lot of other issues, black smoke, maybe even the misfire, potentially damage that cylinder, right? So injectors fail in multiple ways. Screens clog, electrical aspects of the electromagnetic valve fail. The wires can get messed up going to it, or the connectors, or the needle and valve could get dirty and not spray a clean pattern, or it can get so messed up it'll spray all the time when it shouldn't spray, right? So an injector failure could look a number of different ways. A number of different ways. Exactly. So injector failures can vary. Go ahead. All right, let's say if you had a coil, this injector magnetic coil was open. Do you think you'd smell fuel? I don't think so. It just wouldn't open. So you'd have a cylinder that's misfiring, and you'd actually proceed with electrical diagnosis. Not all of them have them. Not all of them have them. All right, but what if we had the injector needle and seat was stuck and the injector was dripping fuel into the cylinder all the time? Do you think you'd smell that? Yeah. Exactly, right? So an electrical failure, no fuel smell. A mechanical failure, if it's leaking, fuel smell, yes. But let's just say that this was clogged up with rust. I don't think you'd smell a thing. The injector would even click, but it would not spray any fuel, right? So when we talk about misfires, I say fuel is the hardest one to get, right? You can check compression easy. You can check spark really easy. And then you're like, well, I think it's fuel. And it'd be like, well, how do I know if it's getting fuel or not? You can listen to the injector. If the injector is not ticking, it means electrically there's something wrong. But if the injector is ticking, that just means this pintle, this needle and seat is moving, but that doesn't verify that there's no rust in the screen. That doesn't verify it's getting a clean spray pattern, right? So it's kind of hard to test them. There's a few tests that we could do. My favorite personal test is you put the fuel pressure gauge on it, you turn the key on, let's say we get 50 PSI, and you go into the scan tool and you say injector balance test, and you command that injector on for 5 seconds, and it should drop, let's say, 10 PSI of fuel pressure. You'll hear the click, you'll go, you'll be like, the injector's working. That's electrically working, but how do I know it flowed the fuel? Because it went from 50 PSI to 40 PSI, right? I know fuel flowed because the pressure went down. The fuel pump primes it up, holds it. It should hold indefinitely. When I pump the injector, it should drop a certain amount. If I did cylinder 1, it dropped 10 PSI, reprimed it back to 50, commanded cylinder 2, it dropped 10 PSI, reprimed it back to 50, commanded cylinder 3, it dropped 0 PSI, and then 4 dropped 10 PSI. What's that tell me? 3 is specifically, though, bad, but in what way? I heard it tick, but I didn't see the fuel pressure drop. The fuel didn't flow through the injector. Now, what's the fix? Maybe replace the injector if you wanted, like when we were broke kids and, we'd be like, oh, we'll work on the neon today, and we'll take it out and try to tap the rust out of it and get some brake clean and carb clean it up. And, you could try to bring it back maybe, but, maybe not. Electrically, if they fail, though, it won't tick at all. And you can't really fix a coil winding in here. If that's the case, it's done. But what if it's not getting the 12 volts in ground from the PCM? We might have an open wire. Maybe a mouse chewed it, right? So there's a lot of different failure points. If you wanted to get into that, you'd look at this. You'd be like, let me look at my diagram. From the relay, it's going to come down here and it's going to provide 12 volts to the injector. The PCM's down here. What's the injector providing? What's the PCM providing? Can you tell? It looks like voltage to me is coming from B+ through the main relay, through the injector fuse, and it's being applied the same voltage to all the injectors on the pink wire, circuit number 5292. I think the injectors have voltage all the time. The PCM's down here, and you see this little switch? What's the PCM turning on and off? Come on, you got this. Injector's got 12 volts all the time. PCM turns the injector on and off by providing or not providing ground, right? So you'd be like, oh, okay, the injector doesn't work. Does it have 12 volts? I'll test it. Remember, we said 3 was messed up. I'll test it right here at A, 12.6 volts. Okay, this side's good. I go down here, no ground. Crank the car. When we crank the car, the PCM should provide a ground. Let's say I get no ground at B. And I'd be like, all right, let me test it down here at E. I get no ground. Let me test it at terminal 4. I get ground. How do I have no ground at E, but I have ground at 4? Bingo. And then you're like, I know it's the wire. You could repair the wire. It didn't need the injector. It didn't need the PCM. You know what I'm saying? But what if you go all the way down to terminal number 4 and there's no ground coming out of there? Yeah, down in here, huh? So the ECM provides the ground. If the ECM has a good ground, it can provide a good ground to 1, 2, 4, 5, and 6. The ground of the ECM is good. It's just this little transistor or switching contact, it's really going to be a transistor, is bad in the ECM. So you're like, this car needs an ECM. Maybe double check yourself because ECMs are pricey. But like, if that's still what you got, the ECM could be bad. There are companies who will refurbish the ECM, but they're few and far between, and I don't know how reputable they are. Yeah, you're probably getting a new ECM. And it's expensive. You could run your own standalone system and then bribe somebody for a Twerco smog, sure. Okay, or what if you go to A and you get 12 volts, and B, you get a pulsing ground, but the injector still doesn't click? How about we make it a light bulb, okay? People visualize light bulbs better. let's say these are light bulbs and light bulb number 3 doesn't light, and I've got 12 volts on the light bulb coming in, and I've got ground for the light bulb. Why isn't the light bulb lighting? Yeah, then the light bulb's bad, AKA the injector itself is bad, right? So right here, you could be like, yeah, that's a bad injector. The previous test would have been a bad ECM. The test before that would have been a bad wire. It could be all of those or any of those. What if the injector fuse was blown? What would we have? No injectors would work. That's not a misfire. That's a crank no start. Make sense? So if I roll up to the car, I'm not even if it's a misfire, I'm not even checking that fuse. Because I know if it was that fuse, none of them would start. If it's a misfire in cylinder 3, I'm really going to start my diagnosis maybe like just down here, after that splice S103. All right, so you can visualize that. It's not that complicated, I think. This is the type of diagram you'd see on the ASE, on A8. And it'd be like, oh, cylinder number 3 injector doesn't work. Tech A says it's an open in injector fuse. Tech B says it's a bad ECU ground. Tech C, this isn't really how to do it, but like another option would be an open between injector number 3 terminal B and E. And you'd be like, yeah, that would lose ground. That would cause a misfire for sure. Right? So understanding it in that way is where we're trying to go. So when we want to test injectors, let me show you another good way. We're talking about, let's just see. We're going to actually locate the injector harness. Right here, let's say this is an orange wire. Let's make that 12 volts. And the green wire, let's make it ground. You can literally just probe on that injector and check for 12 volts and ground. The problem is, and you can do that, okay? The problem is when that injector pulses really fast, it might not really show the pulse on the meter because it's really fast. So sometimes what we'll do is not use a meter, but we'll use this thing called a Noid light. And the Noid light will actually flash when it gets a pulse. That's one of the cleanest ways to do injector. Disconnect the injector, plug a Noid light in, crank it, and the light should pulse. That tells you the injector is getting 12 volts and ground pulsed. Cool. But you could still go to that injector and test for voltage. If the injector has no voltage, you know it's up here. If the injector has voltage, you could check to see if it's getting a ground pulse. It's just a little tough to do on a meter, but you can do it. Or the Noid light's a good option too. There's another thing you could do. You could actually measure the resistance of the injector. Let's say you measured the resistance of the injector, number 1, and this was 20 ohms. Number 2 was 20 ohms. Number 3 was OL. Number 4 was 20 ohms. What's wrong? You measured resistance from terminal A to B of number 3 injector and got OL. That injector's got an open coil inside of the injector, right? So there's different ways to do it. More than one way to test it. That's a good way, right? And then there's quite a few more things you could do, but I like that injector balance test with the scan tool and the fuel pressure gauge the best if it's easy to hook the fuel pressure gauge up. If it has a fuel pressure sensor, that's even better. But when we get into GDI, everything changes, okay? So, and GDI is where we end today, but GDI is gasoline direct injection. That's what's on all modern cars. Some modern cars have port fuel injection in addition to. And there's a discussion for you. The evolution of the fuel systems shows carburetor, throttle body injected, port fuel injected, which was good for a long time, but port fuel injected's out. Gasoline direct injection gives us better fuel economy and lower emissions. It costs more money to manufacture. You get to pay the cost on that. We need to hit our CAFE, and our corporate average fuel economy is CAFE, and we need to hit our emission standards. Government said so, so you're paying for it now. You don't have a choice. All right, so if we look, I mean, we got cars, by the way, anybody just for fun know what like a 2024 Toyota Camry 4-cylinder fuel economy is? 28, 30, what do you think?
Some of them are pretty good.
No, I think it's way higher. It's like 40 something. It's gnarly. So that's what I'm saying. You're 40 plus mile per gallon. So you're like, wait a minute. I got a 2008 Civic getting 28 miles per gallon, and I thought that was good. And I have a Camry, slightly larger car, and it's getting over 40. How did that happen? Well, I introduced to you gasoline direct injection. This is a big part of it right here. They do a little bit more than that. They're doing some stuff with the transmission, torque converter, lockup clutch. They're doing some stuff with Atkinson cycle on the actual engine itself. Like that's why the vacuum readings were weird on the video I demoed, because that's an Atkinson cycle. But a big part of it's GDI, right? So we're getting big numbers. We can do a couple cool things. It's injected directly into the cylinder, separate of the intake event, which will increase the power. We can also run higher compression. And generally we do. That's better for fuel economy and emissions. But when we're running a higher compression, we got to be really careful with our air-fuel ratio. And we got to, have higher processing speed. We got to keep an eye on this thing. And generally a higher compression would mean higher octane. But if we do the GDI right and clean at the right ratio, we can still have you run 87. So that's what we're doing here. So in the day, the 4-stroke cycle, just remember intake, right? On the intake stroke, the intake valve opens and we would suck in air and fuel because we sprayed the fuel way back here. And so the air and the fuel would go past the valve, and maybe a little bit of droplets would get stuck in the intake port, and maybe a little bit of droplets would get stuck on the valve, and a little bit of droplets might land on the cylinder. Those droplets are lost power and lost fuel economy. You understand? And increased emissions. So we eliminated that. Now instead, we have the engine go on the intake stroke. We can spray the fuel directly into the cylinder, or we could wait and we can spray it on the compression stroke. We could spray a little now, a little later, right? We're dealing with timing. We're dealing with a lot of different stuff when it's direct injection, all to increase the efficiency. And truthfully, we've gone away from the traditional auto 4-stroke. In the Atkinson, we're going to start hanging valves open longer. We couldn't really hang the intake valve open longer before because we'd push half the fuel back out. So instead of injecting it on the intake stroke, we're like, no, hold off, do the intake stroke, leave the intake valve open, push half the air back out, then close the valve. You used to have, let's say it's a 3-liter. Now let's make it a 2-liter. If it's a 2-liter and the piston went all the way down and then all the way up, that's 2 liters of displacement across 4 cylinders. Now instead, if we bring it down and we leave the intake valve open, we push half of it out. If half of it's out, we essentially have a 1-liter. You get 1 liter fuel economy when you run it in this Atkinson cycle design. Now, of course, if you're under wide open throttle, be like, no, close the intake valve. Let's get a full 2-liter power. But if you're going down the freeway or just like not really accelerating, but just coasting on this side road, we're going to drop that down to like a 1-cylinder by hanging the exhaust valve open, the intake valve open. Then once the intake valve closes, we're like, yeah, we still need fuel, but we only need fuel for 1 liter rather than 2. The direct injector will spray the correct amount of fuel at the correct time after the valve is closed. It's pretty interesting how they've done it. And then additionally, like, so here's your port injector, right? Air would mix with fuel, droplets would get stuck all over these little places. And it was decent. A carburetor, by the way, the fuel came from way up here at the intake, so there was fuel sticking to the manifold and all sorts of stuff. At least port fuel injector, we were pretty close to the valve. Direct fuel injection, we're after the valve, right? So if I just compare, here's your direct injector. This fuel, all of this fuel is going to get burned. Port fuel, most of this fuel is going to get burned. If you go back to carbureted, some of that fuel is going to get burned, and some of it's going to be smelled. The old cars smell different. They're like, yeah, I can smell that car. Like, yeah, because there's fuel evaporating coming out of the intake because you didn't even burn all of it. You burnt some of it, right? The port fuel car is going to be much more refined. This is going to be even a huge step above that, right? So in GDI, your injector is much larger, and it's spraying directly into the cylinder. Now that presents some problems. Go ahead.
GDI is the one that's it's all the way inside of it.
Yep.
It's hard to take out.
Oh yeah, big time. So if you look at this injector is hanging out right here in your intake. This injector right here is literally put into your cylinder. So it's a much larger injector. Here's the main problem. How much compression did your cars make when we did those compression tests? 130, 150, 175, 180. All right, if your fuel pressure is 50 and your compression is 180 and you open up your injector into the cylinder, what you going to win? Your 50 psi of fuel pressure or your 180 of cylinder pressure? Yeah, you're going to be like, spray the fuel, and the fuel's going to be like, I don't think so. You just open it up to compression. Pow! Send it back. The fuel can't even spray in there. So how do we make the fuel actually spray? We increase the pressure, not to 185, to 4,000. 4,000. We like 4,000, 5,000. So that's the cool thing. But there's another benefit. If we have really high pressure and we have really tiny holes in the injector, it can spray a really, really finely atomized mix. That's better for emissions. That's better for power, right? It's just going to be better for combustion. We like that. But the negative, like I was saying, yeah, now the injector is bigger, stronger, more powerful. It can sometimes take higher voltage to open and close. Sometimes we'll use piezoelectric crystals to actually open and close the pintle. But we also got to have 4,000 psi. You can't make 4,000 psi in that little puny pump we were talking about. So this has got to have a different mechanically driven pump, right? So this system was a big expense. It's a big add-on, but it does give us some really nice fuel economy and much lower emissions. So if you kind of look at that, the injector is going to get us 4,000 or so psi from a hard line. This is not going to be like a rubber line. It's going to be right into the rail or coming from an actual hard stainless steel metal line. No plastic hoses in this thing. No. All right, and then it's going to go directly into the cylinder, which we can control the volume, but we can also control when we spray it. So let's say we wanted to really heat up our catalytic converter because, your car burns cleaner when the cat's hot. How can we heat it up? Let's spray a little bit of fuel on the exhaust stroke for the first 30 seconds. That'll nuke that cat. That cat will be like, whoa, I'm hot. All right, let's go. Then, of course, it'll stop, but it got the cat warm fast. So we can do all that with GDI. That's why your GDI is totally taken over. It's much lower emissions. That's why. All right, so if we spray it directly in the cylinder and we design it different where the air is coming in, hitting this dish in the piston, this is a GDI piston, and it's swirling it up and helping really atomize and mix that fuel up. It's a pretty good efficient method. So you can see, like, here's the GDI piston. That's all for this swirl effect, okay? So that it's not just the injectors that are changed. The pistons are changed to match the injectors. The whole engines have changed to become Atkinson cycle, right? So here it's saying 500 to 3,000. I use 4 because 4 is the most common that I see. And the PCM has to monitor a lot of different things. And ultimately, it's all designed for this, and it has some pretty big improvements. So there's a difference of GDI piston and old school pistons. This one's got this abnormal bowl to swirl it. Cool. And then they can also have valve recesses, because if we're going to hang that valve open longer, we need to make sure the piston doesn't come in and clip it. So this is a modern Atkinson cycle GDI piston. This is like a port fuel injection, auto cycle, typical 4-stroke piston. Cool. So just a little bit different, and they can be different styles too. They could vary, but you can't interchange them. So you can't be putting old school pistons in the new school or new school pistons in the old school. It's not going to run right. Cool. And then speaking of those injectors, here's your old injector. Here's your new one. Why do you think this GDI one looks so weird? It's got to go into the cylinder. So this one had a couple O-rings, right? This is the O-ring that got my coworker fired. This is the O-ring that'll give you a vacuum leak. That gives you a check engine light, but not fire. Okay, this injector is the GDI. It has an O-ring to the fuel rail, but on the bottom, this is not an O-ring. A lot of times it's a Teflon seal, because it's got to go into the cylinder and be exposed to combustion. It's one O-ring at the top and a special seal. So I'll give you a couple little inside points on this. Because this tip of this GDI injector is literally going into the cylinder, there's flame and fire and heat and compression, and it's exposed to a lot more. This O-ring, it's too weak. It's not even close to be able to handle that. Now that one's going to get burnt up. So we don't do an O-ring, we do this Teflon seal. This Teflon seal is a one-time use. These Teflon seals can be sizable, so it's not something you could replace real easy. A lot of times they have an expanding tool to get the Teflon ring in, and once you bolt the injector in, that's it. It's a one-time use. And if you're like, oh, whoops, dope, I forgot, let me pull it back out. Yep, go get another Teflon seal and size it and get it all set up. So for example, if you had a Teflon seal failure, think about this. What would happen if that seal failed and it's poked into the cylinder and it's exposed to compression? I have seen it. I had one come in, and when you ran it, it would go pop, 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 and I checked compression on that cylinder and it was low. And I was like, but I can hear a noise. And so I was thinking it might be that seal. And I pulled the intake off because on this V8, these injectors are under the intake. You can't even see them, but I could hear something. When I take it apart, this is all carboned up. All this area was all black and carboned up. And so when you pull the fuel rail, all 4 injectors come out. So what did I need to do to put all 4 injectors back in? All new seals. But the thing is, I don't have the special service tool, and the special service tool is kind of pricey. And plus, by the time that compression had blown by, I'm kind of sketched out with that injector. So I was like, hey, you need a new one? But if I have to unseat 4 of them to change one new one, and I don't have, so I had to sell them all 4. And then I was like, hey, do you want to do 4 or do you want to do 8? He's like, how much? I said, well, the labor is not that much more to do the other bank because I already got the intake off. So I ended up doing 8 injectors on that, totally hooked it up. Quite a few people have found that video helpful. So this Teflon seal down here on a GDI injector can cause compression loss. Never used to be that way with part fuel. I would. They last a long time. They're good. I did this job at like 150K. Like it was not, they did their job for 150,000 miles. And this guy tows and he goes out to the river. And so his truck's hot. You know, it had a hard life. It had a hard life. Right. So these injectors are just different. We've also seen where these injectors can fail, but they're a little hard to diagnose because you can't just put a fuel pressure gauge on it. You're looking at the fuel pressure sensor. And then, you know, like it's basically if you can check compression and that's good and spark is good and it misfires, you're kind of like, yeah, I think it's the injector, but it's very hard to actually test these. Very hard. And then also because they're bigger and more powerful, sometimes we're running fuel injection control module, FICM, or, you know, a voltage increase. Sometimes we may be running 40 volts, 36 volts, 42 volts, 48 volts on these injectors because it takes more power to open and close a much longer, stronger, more beefy injector. Other times we may be using straight 12 volts, but it could be a piezoelectric crystal that'll open and close it. It's just not a low, basic, simple port fuel injector though. These injectors are like 10 times the price and they take quite a bit more energy to run. So sometimes the way we power these injectors might not come right from the PCM. Uh-huh. Yeah, exactly. They almost look like a diesel injector. I'm not super familiar with the VW. It could be running 12 volts, but it might be running higher voltage. It wouldn't be that hard to find out. Like if I look at this one has actually got its own fuel injection control module. And then you could go into another screen where it would tell you how many volts and it might say higher volts. It'll use a little transformer to increase the voltage. Kind of interesting. And then the tip of these, because these holes are so small, they can tend to get carboned up a bit easier. So remember that whole top tier fuel discussion? The top tier fuels have cleaning agents to keep these clean. If you'll be running some cheapy fuel, Arco 87, which I'm kind of trashing Arco somewhat as a joke, but maybe legit, if you clog up these injector holes, you're probably not going to get those clean. You're probably going to get those replaced. This is the problem. What if you do one injector and the one injector is really clean and the other 3 are kind of dirty? Now there's an imbalance. So we brought in a whole nother set of DTCs now that are a fuel cylinder to cylinder imbalance. So if you have a brand new direct injector and 3 old direct injectors, you may get a cylinder imbalance, which you got to fix that. How are you going to fix that? Probably going to replace the other 3. Yeah, so like, see, if you go into service information and it says if you're replacing one injector, replace all, that's your justification for doing so. Now, once in a while, you can do one injector and have it be no issue, but I would at a minimum let the customer know, hey, you got a bad injector. We'll put one brand new injector in, but if your other 3 injectors are starting to be restricted, you may get an imbalance issue, in which case, you'll have to do all of them. Do you want to do them all right now? And that's kind of where I sold that guy on the V8, that Silverado, was like, I'll put one injector in, no problem. But if you get any imbalance codes, the next bill is on you. I'm no assistance, no help you. Like, now's your chance. No minimum 1 hour extra labor for me to do all of them. And it's kind of like, yeah, all right, do them all. No problems. That was a couple of years ago. And he's been really good, right? So just knowing about this, the same could technically happen on a port fuel injector, but these systems were not advanced enough to know if you have one slightly dirty one and one slightly cleaner one. But these systems are. They're paying a lot of attention. They're looking at your air-fuel ratio on the oxygen sensor or the air-fuel ratio sensor, and it knows which cylinder it had fired when that airflow hit that sensor. So it can tell if there's something a little off on the cylinder. Because again, we're trying to hit that really high emissions and low, very, very, very low emissions number, and that really, really high fuel economy number. Cool. So there's a little bit more to these. Running the top tier fuel is going to be good. Some people would even go for adding a fuel injector cleaner periodically on a maintenance. Not really a bad idea. But I'm not totally, I don't have all the evidence and collection on that. You'd have to test thousands of cars to see if that's helping, but there is at least some logic behind adding some sort of cleaner. Cool. And then overall, these injectors work a little different because they're going to get hot. And so we have coolant passages to carry the heat away. It's the way it's going to work. These newer engines make a lot more heat. They're running a lot more efficient. And then if we talk about the regulator, now here's an overview of the system. We've got, this looks like the same fuel pump as port fuel, but all this fuel pump's doing is just a supply pump. This fuel pump just generates enough fuel to the actual high pressure fuel pump, which is going to generate the 4,000. All right, so it's going to be real similar to your regular port fuel injection pump. It may have a pressure regulator, which may dump it right off into the tank, but then it's going to get up here. There's your high fuel pressure sensor, kind of similar, which is a transducer, but we're really going after this bad boy. This bad boy is going to get your transfer pump, or your supply pump is going to send whatever fuel volume to this. This is going to generate the 2, 3, 4,000. How do you think this mechanical pump would generate 4,000 PSI? A big motor, high voltage? What do you think? Good guess, but no. The computer doesn't make enough power to make that much pressure. Vacuum's a cool idea. Compressor's a cool idea. We're going to actually bolt this to the engine, and the camshaft, that opens the valves. We're going to add another lobe and have the camshaft go like this. Punch, 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 punch. And it's going to have a piston. Poof, poof, poof. Ow, 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 ow. And it's going to pump, 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 pump. That's going to make noise. So we're going to have to dampen some of that noise, but it's literally a mechanical pump bolted on top of the engine that's getting punched in the face all day by a camshaft. It has a really hard job. It's like, hey, 4,000 PSI, please. Pow, 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 pow. And it's like, all right. The whole entire life is just overwhelming. They do fail, by the way. These do fail. They can look like this. They can look a little bit different, but these can potentially fail. They might not make enough pressure. How do you think you'd know if this is making enough pressure or not? It will explode that gauge. Don't even think about a gauge. Connect the scan tool, yes. Monitor this pressure sensor. If it's supposed to be 4,000 and you look and it's like, hey, this thing's only making like 250 PSI on the fuel rail, you'd be like, let me check the mechanical pump. You might have to pop it off and see, like, is there any metal or wear or something? But if the cam looks good and the pump looks visually good, it's probably inside the pump. Would need a high pressure pump. Not a real hard diagnosis, to be honest, but they fail because they have an extremely hard job to do. Extremely hard. And the way we diagnose it's all really with a scan tool. So it's a decent system. And then we do have one that I didn't put it here, but I will, right? So the pressure transducer is just a way to measure that in voltage. Cool. These GDI systems, first off, I actually want to cover this one. Remember that pump, how it's getting punched in the face? Do you think you can hear that? I'd say so. So we're going to put like a little foam on top of it, a little engine cover, a little something, maybe a little dampener, maybe some sort of little dampening spring. We're trying so hard to quiet that down. I remember the very first GDI car that rolled in for me was a Pontiac Solstice. Right? It rolled in and the customer said, "Hey, this got lifter tick." And I was like, "Oh man, it sounds horrible." And then we're like, "Get another one, start up." "Oh, that one does it too. So does that one. This is normal." Customer was like, "No way. No way. It's ticking. It's ticking." It's like they all do it. It's normal. They didn't like the tick. Do you know what the tick was? The high pressure pump. Pa, 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 pa. Tick, 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 tick. And so it was like, no, this is normal. But we do want to try to cover those noises up. So we'll put a little dampener in there. We'll put a little sound deadening in there. We'll put a little pillow over it. Put a little cover over that. But they're noisier. It's just the way it is.
So the customer can't hear it.
Yes, because it's normal. But the customer doesn't like that. The customer's like, "No, I don't want this Solstice anymore. I think it's going to blow up. I think I've got buyer's remorse. I want a lemon law." It's like, good thing I didn't try to repair it. Good thing I wasn't like, "Yeah, let's put a set of lifters in it," because I would have put lifters in it, and guess what? It still would have ticked. And I'd have been like, "Well, what next?" And I've been like, "I don't know. It's normal." And then I've been like, "Nah, lemon law, buy it back." And I would have said, "Well, there's nothing wrong with it." And they would have said, "Well, that's a lie because you put lifters in it. So clearly there is." And I've been like, "I screwed up." And they'd be like, "Too bad, lemon law. You're fired." Oh, I got to rethink my life. Luckily, I compared it to another one. The noises are normal. You can try to mask it. Now, sometimes they could have excessive noise, right? But if you compare it to the same model and it's the same noise, that's how you know it's normal. Okay, makes sense? But wait, there's more. The modes that we do, the PCM can do a lot of different stuff, right? Stratified charge is one of the modes. Low load, when the engine is reducing speed, they'll do this stratified charge mode, which means they can pulse the fuel and then not pulse the fuel and then pulse it. This is a good way to lower our emissions and our fuel economy. Homogeneous operation, that's when we're going to spray like a lot of fuel consistently. It's going to be all mixed up. It's not going to be stratified, right? If you think of stratified as like it's layers, stratified to be like pulse it, don't pulse it. Pulse it, don't pulse it, right? Homogeneous is like milk, homogenated milk. That means the milk with all the cream and everything, the fat and all that, gets all mixed up and it's all consistent. If you get non-homogenized milk, the cream rises to the top. It's not homogenized together. So that's what this is saying. Like, they're not trying to have just air and fuel and air. It's all going to be air fuel. What do you think the ratio is going to be on homogenized or homogeneous? Probably about that 14.7. But if you're under heavy acceleration, they'll actually drop it more fuel, less air to like 12.5 or something. They can very, very precisely control this air fuel ratio. So this is so nice for power. The direct fuel injection has more power. There's no argument. It's not even close. This is really good for power. We can fine tune that exact air fuel ratio. We can fine tune it so that we can get the most advanced timing and not have the pre-ignition and get the most power. These cars run really good, assuming everything's in good condition though. So that's a positive of it. And then we can even transition. We can go between the two, it depends on the acceleration demands, but it's always trying to get the best emissions and the best fuel economy while still giving you the most power. This system's very advanced. Port fuel injection, not so much. They're just like, hey, let's try to hit about 14.7. We'll be a little rich. We'll be a little lean. We'll be a little rich. We'll be a little lean. This thing's like, no, we want 13.2. Boom, there it is. We want 14.7. The other crazy thing, this can do a lean burn where it'll do like a 15.7 rather than a 14.7. When you run it lean, you get really good fuel economy. It could do like intense stuff on the fly. It's pretty neat.
And what time are you putting this on video?
Yeah, and we're going to be done in just a minute. Oh yeah, tell him he'll get it. Yep, for sure. All right, so one problem though. carbon's buildup's a major issue on these. So if you're not running that top tier fuel, and probably honestly, even if you are, we're going to tend to get carbon on the valves. You see how nasty that is? That's because back in the day, the port fuel injector would spray fuel and the fuel would kind of clean this. But now, because there's no injector in the port, all the fuel's being sprayed past the intake. When this intake valve opens up, there might be a little bit of like leftover something and it kind of collects on the cold valve. It never gets cleaned. So we need to clean these periodically. The top tier fuel is going to be critical, but also these may need like a top engine clean, you know, or even like walnut blasting. This is more maintenance for technicians. If it gets that much carbon, it'll actually misfire.
Or if you put something in your fuel out.
It could hopefully help maybe. I don't know. You know what I know works? Me cleaning them. They have GDI spray you can clean and it'll soak on those, and then you'll start it up and a bunch of smoke will come out the tailpipe and you'll be like, oh, they're clean now. Walnut blasting is another common thing. You actually close the valve and you literally blast air pressured walnuts onto this and it'll break all that up, and then you vacuum up the dirty busted walnuts. It sounds crazy, right? But it's true. We're doing more maintenance on these. It's just everything's great about the power and the better fuel economy and emissions, but then the customer's like, I got 60,000 miles in a misfire and you're telling me I need to clean my valves and clean my injectors? Like, this system sucks. But it's like, well, it gave you the better fuel economy and emissions, but it needs more maintenance. I'm sorry. You know, it just is what it is. No, you can do it with the head on, but you got to have the intake off and do your walnut blasting. You got to be able to access that valve pretty good. You could do, you know what you could do? You could do a sea foam, and it may or may not help a lot, but it'll help a little, where you can put a little hose on your intake and dip your little hose in your little sea foam and let the engine slowly but surely pull up a little sea foam, and that'll hopefully break some of this up. There's all sorts of ideas. I'm just saying, back when it was port fuel injection, we didn't really have this. And on GDI, we do. Just sorry to break your heart. And same with the injector, you know, these can get carboned up. Like, it just needs, these need more maintenance. They're in a harsher environment. They're not chilling in the intake port anymore. They're in the cylinder exposed to the flame. Kind of makes sense? Okay, so here's a crazy idea. What if we did both? Okay, now this is a positive Toyota plug. Domestics don't do this. Toyota, Lexus do this. They'll have direct injection with all the power and all the fuel economy and all the positives. But you know what they'll periodically do? They'll spray port fuel injectors just to clean the valves. Like, are you serious? So you got a V8 with 8 direct injectors, and you add another 8 port fuel injectors on top of it. You got direct injectors down here, and you got port fuel injectors right here, and we'll go back and forth between the two in a strategy to keep your valves clean. So you don't have to do your walnut blasting and your GDI spray and your additives and your sea foam and your whatever stuff. So that's a little bit more where the Japanese are positive. It's not all positive. They won't give us a stinking fuel pressure checkpoint on the fuel rail. You know, we keep asking for it. But in the positive, they're like, you know what? These valves are going to get carboned up. They take it personal when their cars have any sort of failure. So they're kind of like, we're going to add a whole nother set of 8 injectors on there, so this never fails. We don't ever want to hear our system was bad. So more money though. More money, less maintenance. Here's a crazy thing about one of these. Recently, former student who graduated from here actually, who owns their own shop in Temecula, had a customer came in. Actually, it's in Murrieta, but it's right on the border. Same thing. Customer came in. Concern was a misfire. Did some of the initial checks. Spark test good. Moved the coil just for the heck of it. Didn't follow. So we know what's on that cylinder. Let's say it's cylinder 2. I actually don't know which cylinder it was. But okay, that's good. Check compression. Compression's good. What's left? If it's got good spark, good compression, what's left? Fuel. So it's compression and spark is good. Fuel's left over. What's wrong with the fuel? I don't know. Wait a minute, this system's got direct injector and a port fuel injector. Is it a problem with the direct or the port? I don't freaking know. So he called me and I was like, you know what? I haven't seen that really, but let me talk with some people, talked to a couple of former students, friends, some tech people, and we all kind of agreed on how to proceed with the diagnosis. There's a function in the scan tool where you can switch direct injection or port fuel injection. So we said, hey, go in there, change it over to port fuel injection, see if it misfires. Then change over direct fuel injection, see if it misfires. So this is what the former student technician did. Put it on port fuel injection only, misfire totally cleared up. And it had that fuel imbalance too. Change it over to direct fuel injection only, misfires right there, bumbling, stumbling, running all sorts of crappy, set the misfire code, set the fuel cylinder imbalance code, and it was like, well, bunch of lights, Christmas tree lit up. So what's the problem? Ran good with only port, ran bad with only direct. Bingo. So he's like, hey, it's a direct injector. Needs a direct injector. But knowing that it has a cylinder imbalance code, cylinder imbalance code more means like you got one cylinder that's running a little more rich or a little more lean than the other ones. These cylinders not balanced. It was like, hey, you know what? It's a V6. You probably really need to do 6 injectors. We could do 1 injector for you, but if you come back with the cylinder imbalance code, like, you know, you're going to have to do the other 5 and pay the labor again because we're going to be right there. You sure you don't want to do all 6 of them? You know, and so the customer declined, but he did 1 injector and actually it repaired it. Then, of course, come to find out later, the customer had been to the Toyota dealer already, and the Toyota dealer sold him 6 direct injectors, and they just didn't like the price. So they brought it to the independent shop, who then redid the diagnosis, came up with the same diagnosis, but was willing to do like 1 injector and see how it went, whereas the dealer's like, nah, 6 or nothing, get it out of here. You know what I'm saying? So a little difference between the independent and the dealer. So that's pretty much what I got on direct injection. And just to kind of get a little bit into like where we're going, when we start to talk about the fuel injection control, that's more about the air fuel ratio. Okay, so this will just get your mind started. Next week, it'll be a little bit of review before we get crazy into there. But when we look at this air fuel ratio, it could have to do with the fuel pump, the fuel filter, the injectors, the fuel pressure regulator, and a bunch of sensors, right? So if you have a vehicle that's running too rich or too lean, it could be a sensor issue, right? It could be, but it could also be all these supply components. And that's why I want to cover supply first. So if you got a car that's getting not enough fuel and too much air, it could be a weak pump. It could be a clogged fuel filter. It could be your injectors are dirty, right? So you got to know that. Exactly. Before you're even ready to start talking about, well, maybe it's these sensors. So the sensors, what we're covering next time, we got a lot of inputs: mass airflow, manifold absolute pressure, coolant temperature, throttle position, engine speed, oxygen sensor. All those are inputs so that the computer can determine how much to run the injector on time to get the exact 14.7, right? But again, all these sensors are going to fine tune it, but you got to assume that all these supply parts are correct. They're working right. So we might have to test these before we even start to really look at these. And sometimes we'll get something like a coolant temperature sensor will read wrong, and that'll throw all of our numbers off and the car won't run right. But sometimes it's kind of hard to find out that it's the engine coolant temperature sensor. Sometimes we think it's this, but it ends up being the fuel pump or something, right? So these go together, but we start with one. The outputs on that would be injectors, ignition timing, idle, fan relay, fuel pump relay, right? So there's the input, process, and the output. That's what we're going into. And then just as an overview, there's a couple types. We could measure airflow with the mass airflow sensor, or speed density, which is more going to look at like throttle position and manifold pressure. So there's different types. Here's your MAF. The MAF is going to measure the air, so therefore it should be able to predict the fuel. But it measures the air, but it needs to know the temperature of the air, and it needs to know the temperature of the coolant. It needs to know all this stuff. Whereas then, like, if we had an issue with such as maybe a leak in the tube or low fuel pressure or whatever, it would maybe not be picked up by the MAF, and it might not have a spray the right amount of fuel. And that might be because of a tear in the hose, or it might be because of a bad fuel pump, or it might be because of a bad mass airflow sensor, right? So things are going to get kind of complex when we start to troubleshoot the actual fuel injection system that has to do with the air fuel ratio being correct, okay? So that's where we're going next time. You guys made it. Very nice job. You made it. It was intense though, huh?
That was bad.